On the night of October the 20th, 2025, the universe seemed perfectly ordinary. The air above a small American town was still the hum of streetlights faint, the temperature just cool enough to make the air bite the skin. In a quiet backyard at the edge of suburbia, an amateur astronomer known online only as Dobsonian Power set up his telescope for what he thought would be an uneventful session. He had no grant, no observatory, no staff, only a patched-up mount, a set of solar filters, and the patience that has always separated astronomers from dreamers. His modest goal that evening was to photograph the region near the Sun, an area most amateurs avoided because its glare overwhelmed everything around it. But he had been chasing something faint, a rumoured interstellar comet named 3IATLAS, that according to predictions would pass close to our star that week. If these mysteries have you on edge the way they have me, don't just watch, join the hunt. Hit like and subscribe so you don't miss a single revelation as this story unfolds moment by moment in real time. Tell me in the comments where you're watching, from what time it is there, and whether you believe we're hearing the whole truth about what's unfolding above our heads. And if you want to keep the signal alive, share this video on X, Facebook, Reddit, or even just with the people who still look up at night. You are the reason we can keep following the impossible, and for that, thank you. He adjusted the focus, shielded his screen from the glare, and captured a series of short exposures. The files looked ordinary at first, just the bright halo of the sun's edge, a few digital specks, faint noise. Then one frame stopped him cold. There it was, a sharp pinpoint near the solar limb, brighter than expected, perfectly defined. At first he thought it was a reflection, or a sensor flare, but as he stacked the frames and subtracted the noise the pattern held, a solid object, a visitor gliding just beyond the furnace of our star. He uploaded the raw, unprocessed image online as he always did, posting to a small astronomy forum with the modest caption, "Object near the Sun." Possibly 3IATLAS. No visible tail. Within hours that line, no visible tail, set off a digital tremor. For months, professional astronomers had been tracking 3IATLAS, classifying it as another interstellar comet, the third of its kind, after Oumuamua and Borisov. It was expected to behave like all comets do approach the Sun sublimate, under its heat sprout a long luminous tail of gas and dust, then fade into the dark beyond Neptune. The prediction was routine, textbook absolute. But Dobsonian Power's image didn't fit. The object unmistakably near the Sun had no tail at all, not even a faint coma, a diffuse glow that every comet displays when its frozen gases vaporize in sunlight. Instead, the space around it was clean, dark, untouched. To anyone who understood cometary physics, this was as if someone had lit a fire that refused to give off smoke. The Sun's heat should have turned 3IATLAS's ices into gas streaming millions of kilometers outward, forming that unmistakable streak across the sky. The process called sublimation is as predictable as gravity itself. When ice meets sunlight in a vacuum, it becomes vapor instantly. Yet here was an interstellar object, basking in solar radiation, without any sign of melting. As the image circulated, the astronomy community split in two. Some said it was an exposure error, a filter glitch. Others examined the pixel data and found it consistent. The coordinates matched the predicted path. The luminosity matched the estimated magnitude. The only thing missing was the very thing that defined a comet. Through the following day, the conversation expanded beyond hobbyist forums into scientific circles. A few observatories quietly repointed their solar cameras. Reporters called NASA for comment and got only polite deferrals. But among those who had seen the photo with their own eyes, an unease began to grow because the violation was too fundamental to dismiss. The tail of a comet isn't decoration. It's physics incarnate, a signature of heat and motion that binds celestial mechanics to chemistry. When that signature vanishes, something deeper is broken, either in our understanding or in nature itself. In that single backyard image, the universe had committed a small act of rebellion. A star still burned as it always had, light still travelled at the same speed, but one small traveller near the Sun was ignoring the oldest rules. And so the questions began to multiply faster than the pixels that carried them across the internet. Was the photo real? Was the object misidentified? Was it even natural for scientists accustomed to order? It was the first shiver of vertigo. For dreamers, it was an invitation. Under that same October sky, unaware of the storm his image would ignite. The man behind the telescope simply leaned back, gazed at the faint glow above the horizon, and wondered aloud the question that would haunt the months to come. How can a comet exist without a tail? In the language of the cosmos, a comet's tail is not an accessory, it is its identity. Whenever a frozen traveller drifts too close to the sun, the result is as inevitable as dawn. Heat meets ice. Ice turns to gas. Gas escapes into the vacuum, forming a luminous stream that flares like a torch in solar wind. It is a dance that has played out billions of times since the birth of our solar system, a ritual of matter bowing to energy. That ritual did not happen for 3IATLAS. If physics were a contract, this comet had just broken it. To understand why the image from Dobsonian power was so disturbing, you must picture what should have been seen. Imagine a solid nucleus just a few miles across, made of rock, dust and ices older than Earth itself. For eons, that nucleus wandered through the interstellar dark, frozen to the temperature of liquid nitrogen, a silent ember in endless night. Then, drawn by chance and gravity, it crossed into the inner solar system. Here, sunlight is no longer gentle, it is a hammer. At this distance, every square meter of surface receives enough energy to melt steel. Any ordinary comet entering this zone erupts into activity. The ice's water, carbon dioxide, methane, ammonia skip the liquid phase entirely. They sublimate, transforming directly from solid to vapor, bursting outward in jets that drag dust along with them. That is the physics. That is the law. And every comet we have ever studied has obeyed it. The escaping vapor forms a glowing cloud called the coma, often hundreds of thousands of kilometers wide. From that coma, sunlight and the solar wind sculpt a tail, sometimes two one, of dust bent into a graceful curve, and another of glowing ions, blue and straight, pointing directly away from the sun. These tails are not decorations. They are mechanical consequences of light and plasma. To look at a comet near the sun and see no tail at all is like watching a bonfire that gives off no smoke, or a speedboat slicing through water without leaving a ripple. The physics does not merely fail to add up, it collapses. This is why the backyard photo struck professionals like an alarm. It wasn't just odd, it was impossible. There are no known materials that could survive such proximity to the sun without shedding mass. Even metal would boil away. And yet the object in the image, small and dark, sat unbothered, clean-edged, serene. Within hours of the post, observatories attempted to confirm it. Some caught brief glimpses through solar filters, each one repeating the same story: no coma, no tail. A few instruments registered a faint glow around the object, but nothing that matched the vast flowing plume of a typical comet. Whatever 3IATLAS was, it was not responding to solar energy the way it should. The contradiction left scientists grasping for possibilities. Could it be that the object was made of exotic ices, frozen gases that refused to vaporize? Unlikely. Even carbon dioxide and carbon monoxide, the most stubborn ices, would sublimate long before reaching that distance. Could it be coated in dark dust and insulating shell that trapped its heat? Perhaps, but the image showed brightness where it should be dim. The logic looped back on itself, tightening. Each explanation contradicted the next. As the debate spread online, something unusual happened. Silence from official channels. NASA, ESA, the major observatories all released nothing. The object's official tracking updates continued as scheduled, but without commentary. No new imagery, no press briefings. The world was left with a single haunting photograph, and a puzzle that felt almost alive. For those who stayed awake through that October night, scrolling through threads and magnified pixels, there was a strange electricity in the air, a mix of scientific fascination and something older, more primal wonder sharpened by fear. Because the cosmos had always seemed predictable, governed by equations that fit neatly on whiteboards. And now a small point of light near the sun was whispering that perhaps we did not know the rules as well as we thought. By morning, the image had circled the globe. News anchors tried to describe it using phrases like unusual solar behavior or rare cometary anomaly, while comment sections filled with theories ranging from camera error to alien technology. The world had awakened to a new kind of curiosity, one that carried a pulse of dread. For centuries, comets were seen as omens, celestial messengers of plague or change. Modern science had cured us of that superstition, teaching that they were simply frozen archives of the early solar system. But that night, the boundary between myth and physics began to blur again. If the universe could present a comet that defied the very process defining comets, what else could it rewrite? The photo was simple: one dark spot against a halo of solar light. Yet inside that dot, the laws of heat, motion and matter were being quietly mocked, and around the world astronomers sat before their screens replaying the same impossible question: if a comet feels the heat of the sun, why doesn't it burn? The more the image was examined, the stranger it became. What Dobsonian power had captured was not merely a comet without a tail, it was something that seemed to possess the reverse of one. A bright fan-shaped glow extended not away from the sun but toward it, as if the object were shielding itself against the solar blaze. Astronomers who saw the enhanced contrast version called it the shield. It appeared as a thin, radiant arc facing directly into the sunlight, while behind it, the direction where every comet's tail should stretch, lay only clean darkness. To the untrained eye, it might have looked beautiful, a pearl-like flare standing bravely before the furnace of the sun. But to physicists, it was a logical earthquake. In every model of solar dynamics, sunlight and the solar wind push outward. Photons carry momentum. Charged particles stream continuously from the sun in a hurricane of plasma. These forces sweep dust and gas away from a comet's surface, sculpting the elegant tail we expect to see. Nothing in that environment points toward the sun. Nothing resists the pressure it yields, it flows, it flees. Yet this glow, this strange forward-facing brilliance, did the opposite. It looked not like something being pushed, but something holding firm. It behaved as though it were reflecting or even redirecting solar energy instead of absorbing it. The comparison was irresistible: a heat shield. Engineers who design spacecraft understand this principle well. A probe approaching the sun must protect itself with reflective panels often coated with exotic materials to deflect radiation. The Parker Solar Probe, for instance, carries a carbon composite shield capable of enduring temperatures over 1300 degrees. The glow on 3IATLAS resembled that same idea scaled up to cosmic proportions, an active surface facing the star bright because it was fighting back. And there was another anomaly. In several frames of the original sequence, observers noticed a faint cone-shaped puff emerging from the object's dark nucleus, but it wasn't moving in the expected direction. Instead of streaming away from the sun like ordinary jets of sublimating gas, it angled off, slightly diagonal, precise, almost aimed. Natural outgassing is messy. When pockets of ice explode under sunlight, they erupt at random, throwing jets in unpredictable directions. But this puff was small, clean-edged and brief, as though it were controlled. A single, measured burst. It was easy, perhaps too easy, to see intention in that line of light. Some amateur analysts overlaid it on trajectory maps, arguing that the puff's direction matched the exact vector needed to maintain 3IATLAS's orbital course as it approached the sun. If true, it would mean the object wasn't drifting, it was correcting itself. Professional scientists cautioned restraint. Optical artifacts, they reminded, everyone can mimic structure. Solar filters can invert brightness, making shadows appear as light and vice versa. But the human brain, shaped by millennia of seeing patterns in clouds and constellations, could not help but perceive design. We are creatures built to find faces in randomness, to hear whispers in static. It's the same instinct that guided ancient stargazers to draw hunters and lions across the night sky. And now, centuries later, that same pattern-seeking machinery fired again, this time over a handful of pixels near the sun. Forums lit up with speculation. Some saw the shape of a shield. Others claimed to discern hexagonal symmetry like panels or plating. A few insisted the glow pulsed faintly as if powered. It was absurd perhaps, but within that absurdity lay the beating heart of curiosity, the willingness to look at the inexplicable and ask what if. To imagine that something could resist the sun itself, could stand in the face of its wind and not be destroyed, was intoxicating. It suggested technology far beyond ours and engineering that made our heat-resistant alloys seem primitive. If true, it would mean that 3IATLAS wasn't surrendering to solar physics. It was negotiating with it. But science moves on evidence, not wonder. Teams in Europe and Japan tried to reproduce the image using solar observatories, comparing different wavelengths to test if the shield was real or an illusion of contrast. Some reported faint confirmation of a bright front-facing region, though less defined than the viral photo. Others saw nothing unusual at all. The data was as divided as the human reaction to it. For those who preferred rationality, it was still a comet, just a weird one. For those who sensed meaning in its defiance, it had already become something else, an emissary, a machine, a mirror reflecting the limits of our understanding. It is here in this space between data and imagination that the story of 3IATLAS truly begins, not as a catalogued object, but as a thought, a question taking shape against the solar fire. Because when nature misbehaves, we look for intelligence, and when we think we see intelligence, we start to wonder whether the cosmos has finally decided to look back. The photo hit the internet like a spark falling on dry grass. At first it was just another backyard post, an obscure image from a small astronomy forum time-stamped and tagged with coordinates that only enthusiasts understood. But by dawn on October 21st, the link had escaped its orbit. It crossed from private discussion boards into Reddit threads, then twixt TikTok and global news aggregators. The caption that followed it everywhere was deceptively simple: 3IATLAS no tail. For astronomers, those 3 words were dynamite. Within hours, online communities devoted to astrophotography were dissecting every pixel. Some magnified the bright region facing the sun, tracing it with digital rulers and arguing about geometry. Others adjusted contrast curves, claiming to see symmetry too perfect to be natural. The longer people stared, the more detail they convinced themselves they saw a repeating pattern of light, a thin ridge, even what looked like paneling. Across time zones, screens glowed through the night. Amateur sky watchers compared notes from Brazil, Spain, and Japan, each promising to check their archives for earlier sightings. Discord servers turned into impromptu control rooms, with users calculating orbital paths, debating filter artifacts, arguing about solar scattering angles. The tone shifted from curiosity to something that felt like collective adrenaline. But as the grassroots debate exploded, professional institutions went quiet. NASA's solar missions posted routine telemetry but no images. The European Space Agency released a brief note confirming that 3IATLAS was on trajectory, nothing more. Journalists called for comment, but press officers deflected data still under review. The Harvard-Smithsonian Center for Astrophysics, where questions like this usually found their answers, said nothing. That silence was deafening. The absence of official statements became a vacuum that public imagination eagerly filled. Speculative videos popped up hourly. Comet or craft. Alien heat shield discovered, NASA knows. One channel even uploaded a dramatic reconstruction of the supposed sunward shield, accompanied by orchestral strings and the claim that world governments were suppressing the truth. Meanwhile, within academic chat groups, the conversation was far more restrained, but no less electric. A few senior astronomers privately admitted the image looked genuine, at least in terms of exposure and scale. Others suggested it might be a rare observational angle, perhaps the tail was hidden directly behind the nucleus, seen edge-on invisible against the solar glare. Possible, yes, but improbable. In the quiet corridors of observatories, there were arguments not about aliens, but about reputations. No one wanted to be the first to say artificial. No one wanted to risk their career on a viral image from a backyard telescope. It was safer to wait for data to let the mystery breathe a little longer. So the amateurs kept talking while the professionals held their breath. By the second day, the image had reached mainstream news. Morning anchors described it as a strange comet sighting, causing confusion among experts. They showed an animated sun, a glowing dot, and smilingly promised updates as NASA investigates. But NASA said nothing. And in that void of authority, the internet created its own. Citizen analysts uploaded hour-long breakdowns comparing 3IATLAS to known comets. Others ran simulations showing that a typical comet near that distance should have a tail millions of kilometers long. If the physics is right, one viral post read, "Then this isn't a comet, it's an argument." Hashtags bloomed like constellations: no-tail comet, sunward shield, 3IATLAS mystery. Underneath the noise, a few sober voices tried to restore calm, explaining sublimation, solar scattering, and why extraordinary claims require extraordinary evidence. But reason is quiet online. Wonder is loud. As the image spread, even people who had never looked through a telescope felt the unease. The photo didn't look like much, a faint dot beside a bright star, but its simplicity made it powerful. It wasn't filtered, dramatized, or narrated. It was raw truth, unmediated, and that made it terrifying. For centuries we have believed that the sky, though vast, was predictable. Planets moved by equations. Comets obeyed the sun. Our instruments captured beauty, not rebellion. But this one frame, captured by a single hobbyist, had cracked that quiet order. By the time night fell again, professional astronomers were locked in private conference calls while ordinary people scrolled their phones under the same sky, whispering the same question, what if this was real? For one strange evening, humanity felt the weight of the unknown pressing closer than any star, closer than comfort. The universe had twitched, and for the first time in living memory, science itself blinked. Before the controversy, before the late-night debates and the theories that burned across the internet, comets were simple things, beautiful, yes, but obedient. They followed rules we understood, written in the patient language of heat, ice and sunlight. For centuries that obedience comforted us. A comet begins its life far from warmth, in the cold, dark reservoirs beyond Neptune, the Oort cloud, a drifting sphere of icy debris left over from the birth of the solar system. Out there, a comet sleeps for millions of years, locked in darkness so deep that even sunlight cannot reach it. Its heart, called the nucleus, is a dirty snowball, frozen water, carbon dioxide, methane, ammonia, and dust pressed together like ancient frost. Then a whisper of gravity disturbs it. A passing star, a planetary nudge, a subtle resonance, and the comet begins to fall inward. It drifts toward the sun on an orbit so vast that it may not return for millennia if ever. As it nears the inner solar system, sunlight touches it for the first time in eons. The transformation is sudden, almost theatrical. Ice awakens. Heat bores through the crust. Gas bursts outward through fissures carrying clouds of dust into space. Around the nucleus, this escaping material forms a glowing atmosphere, the coma. It is not solid, not even stable, but to our eyes it looks like a halo, the visible soul of the comet emerging from its frozen shell. From this coma, two distinct tails unfurl. The dust tail curves gently, a pale yellow or white stream of microscopic grains pushed by sunlight. Because the sun's radiation pressure acts unevenly on different particles, the dust tail forms a graceful arc, like the stroke of a celestial brush. It is the tale of history, the one humans have watched since before we had telescopes, the one that inspired awe and fear in equal measure. The ion tail, by contrast, is a thing of physics and plasma. When solar wind, a torrent of charged particles, strikes the comet, it strips electrons from its gases, creating ions that glow in ghostly blues and greens. Magnetic fields sweep these ions straight back from the sun, forming a narrow luminous spear. Unlike the dust tail, the ion tail does not curve. It always points directly away from the sun, a compass needle written in light. Every comet obeys these forces. Every tail points the same way. From the smallest fragment to the great showpieces like Hale-Bopp or Neowise, the geometry is universal. It is one of the few celestial certainties we can depend on the sun blows and comets yield. Humans have been watching this pattern for tens of thousands of years. Cave painters at Lascaux may have drawn it as a streak across the ancient sky. The Babylonians recorded comets as omens of kings' deaths. In China, imperial astronomers catalogued their shapes: broom stars, sword stars, banner stars, believing each foretold a different kind of destiny. Even the word disaster comes from the Latin dis astrum, bad star, and yet beneath all that superstition lay a kind of reverence. A comet's arrival reminded us that the heavens were alive. It was a messenger of change, yes, but also of connection. The same sun that warmed our crops sculpted these distant travellers. The same light that guided our seasons carved their luminous arcs. In modern times, we learned to understand rather than fear them. Spacecraft like Giotto Deep Impact and Rosetta approached comets up close, confirming that they were indeed ancient, porous and simple. We watched as Rosetta's lander, Philae, bounced across the surface of Comet 67P, measuring dust grains and tasting its gases. Every observation reinforced the same reassuring conclusion: comets were relics, not mysteries. Their beauty lay in their predictability. To a scientist, they became living fossils, archives of the solar system's youth, telling us what our world was made of before it was born. To poets and philosophers, they were reminders of time itself, cycling back from the deep to whisper of beginnings. So when 3IATLAS appeared, everyone thought they knew the script. It would warm, it would bloom into a glowing coma, it would trail a shining tail that always pointed away from the sun. Cameras would capture its light. Students would model its orbit. Then, like all comets, it would fade into darkness once more. That was the lesson we thought we knew. But knowledge, like ice, can crack under pressure. And when Dobsonian Power's image appeared, no coma, no tail, no obedience to light, that lesson began to fracture. For the first time in generations, astronomers found themselves staring at the sky not with comprehension, but with wonder. The old equations still worked, but they no longer explained. The logic of sunlight and sublimation, the eternal grammar of comets had been quietly rewritten. Before that moment, the heavens had seemed steady, predictable, safe. After it, every glowing tale in history felt like a promise that had just been broken. If the cosmos were a classroom, 3IATLAS would be the student who rewrote the exam questions. Everything about it contradicted what the universe had always promised would be true. When astronomers compared its behavior to the tidy lessons of comet physics, the contrasts glared like warning lights. No coma, no dust plume, no gas streaming from the nucleus, and most unsettling of all, a luminous flare facing the sun, the mirror image of every comet ever recorded. It was not just a comet that refused to behave, it was an anti-comet. In simulation models, an ordinary comet is chaos in motion, rotating, shedding, expanding, changing brightness as it breathes sunlight. But when telescopes turned toward 3IATLAS, its light curve remained eerily steady. No flickering, no pulsation, no sign of the random outbursts that mark a living, vaporizing body. It was as though the object were made of something immune to heat, something perfectly indifferent to the solar furnace, bathing it in billions of watts of radiation. To observers, it was like watching a bird soar without feathers, or an ocean that moved without tides. The physics that should have sculpted it simply did not apply. Some early analyses suggested it might be a fragment of metal, dense, polished, highly reflective, but that too unraveled under scrutiny. If it were metallic, the intense solar radiation should have driven its temperature high enough to vaporize any known alloy. Yet 3IATLAS held its composure, not melting, not dimming, not evaporating. Its orbit remained clean and exact. Its brightness did not change as expected when it approached perihelion. Its surface, as captured in higher contrast imagery, appeared smooth, not jagged or dusty like the rocky ice balls we have studied for decades. Whatever this was, it wasn't crumbling. It was enduring. By late October, as it neared its closest pass to the sun, the data coming from small observatories in Chile, Hawaii, and southern Spain began to show a troubling pattern. The object was not just resisting sublimation, it was maintaining a precise attitude, as if something within it was stabilizing its orientation. When light curves are plotted for ordinary comets, they oscillate, brightening as they vent, gas dimming as jets rotate out of view. But the graph for 3IATLAS was a flat line. Stillness, perfection, constancy. It's as if it doesn't care that the sun exists, one astronomer murmured in a private chat thread that would later leak. The phrase went viral. It became the shorthand for everything unsettling about the discovery. Because if comets are supposed to react to sunlight, then something that refuses to react is either made of a miracle material or not a comet at all. The metaphors grew more desperate as people tried to describe it. An iceberg that will not melt. A candle that burns without flame. A moth that circles the light but never chars its wings. Every rule it broke deepened the mystery, but it also deepened a quiet, almost spiritual sense of unease. Because behind every broken law of physics lies one of two explanations, either a new kind of nature or intention. Some scientists clung to natural theories. Perhaps 3IATLAS was a super-refractory object made of elements we rarely see, like pure nickel or silicates, encased in carbon glass. Others speculated that its apparent stability might be an illusion, caused by viewing geometry. Maybe the tail was simply hidden behind the nucleus, invisible against the solar glare. But as data piled up, each of these defenses collapsed one by one. The spectral readings did not match ordinary rock. The albedo, its reflectivity, was far too high for carbon. Its temperature was too low for exposed metal. What remained was a collection of impossibilities strung together, orbiting the sun with unnerving precision. It behaved like a comet, stripped of all cometary qualities, as if the word itself had lost meaning. When Oumuamua, the first interstellar visitor, passed through our solar system in 2017, it had startled us with its shape and acceleration. But 3IATLAS seemed to go one step further. It erased the very identity of what we were seeing. A visitor from another star that neither burns nor melts, that carries light on its forward side, and that moves as though guided by an unseen hand. Night after night, astronomers stared at data streams trying to fit this object into a category, and the category refused to exist. It was a silent contradiction gliding through sunlight, proof that the universe could still behave like a riddle. In every sense that mattered, 3IATLAS was not a comet at all. It was its reflection in a broken mirror, obeying opposite laws, following reversed instincts like a cosmic negative of everything we thought we understood. And as it drew closer to the sun, the question whispered through every observatory and every late-night chat thread grew harder to suppress. If it wasn't reacting to the sun, then what or who was it reacting to? By the morning of October 21st, 2025, the strange traveller had reached the edge of invisibility. Telescopes that had been following 3IATLAS since summer watched their tracking software flash an inevitable warning object entering solar conjunction. For anyone new to the language of astronomy, conjunction sounds gentle, like two bodies meeting in friendship. In truth, it's the opposite. It means the sun has come between us and the object. From Earth's perspective, 3IATLAS had slipped behind the solar disk, vanishing into the glare. No ground-based telescope could follow it. No camera could capture it without being blinded. The world's instruments were forced to blink just as the mystery reached its brightest, most crucial moment. Imagine standing on a shoreline watching a ship approach through morning fog, and just as it nears the harbour, the sun rises behind it, turning everything to blinding gold. For days you can see nothing. You only wait, guessing what shape will emerge once the light softens again. That was October 21st, the day the universe pulled the curtain. Solar conjunctions are common in astronomy. Every planet and asteroid at some point passes behind the sun from our viewpoint. Normally we shrug and wait a few weeks for the geometry to shift, but this time the timing was too perfect, almost taunting. 3IATLAS had been defying the laws of heat and light for weeks. It had resisted vaporization, held steady brightness, even produced a shield that pointed into the solar wind. And now, just as global attention reached its peak, just as instruments were beginning to collect serious data, it stepped neatly into the one blind spot no observatory can overcome. Behind the sun lies the great astronomical blackout, a region even our most powerful telescopes must surrender to. The sun's brilliance floods every detector, every sensor. For spacecraft like SOHO or Parker Solar Probe, special filters can sometimes glimpse the edges, but direct observation is impossible. The very source of light becomes the perfect veil. In ancient times, such moments carried superstition. When a planet disappeared behind the sun, astrologers spoke of death and rebirth, of gods retreating into fire. Now, with all our equations and cameras, we like to think we've outgrown those myths. Yet as 3IATLAS slipped into that forbidden zone, the same unease returned, quiet, irrational, but persistent. It was hiding, and not just anywhere, but in the one place no one could follow. Astronomers comforted themselves with schedules the object would reappear within 2 weeks, moving toward perihelion, its closest pass to the sun, on October 29th. They mark the date on their whiteboards, confident the mystery would resume then. But in the long nights between, a question began to haunt the data analysts and graduate students who stayed awake staring at silent screens. What happens behind the sun? We assume that a comet merely passes through unaltered, illuminated from behind, but there is a deeper, quieter fear that things hidden in that glare could change unseen, or act unseen. The idea was absurd, of course, yet timing has power. If one wished to make a maneuver to alter course or release smaller fragments, there could be no better moment than conjunction. No eyes, no recorders, no proof. In the following days, the feeds from NASA's solar observatories went through their normal rhythms: coronal mass ejections, solar flares, the churning plasma of our star. But among those frames, amateur sleuths noticed tiny inconsistencies, faint streaks, brightening spots, data gaps. Most were dismissed as calibration noise. But to those watching with more imagination than caution, it felt like whispers through static. One online post summed up the mood it hid in the light. Across observatories, the waiting became almost physical. Telescopes idled like hunters forced to lower their scopes. The air of frustration turned into a kind of awe, because in a universe of infinite openness, it was a strange thing to encounter something that could choose when not to be seen. And so the days passed. October's sunlight burned across the horizon, and humanity with all its technology found itself staring at the one star that blinds it, knowing that somewhere behind that blinding disk, an object from another system was passing silently, deliberately and unseen. It was a cosmic irony too perfect to ignore. When the moment came for 3IATLAS to reveal its truth, it vanished instead, hiding not in shadow, but in light itself. On October 29, 2025, the universe's clock struck its most critical minute. That day, 3IATLAS reached perihelion, the point in its orbit where it passed closest to the Sun. For an ordinary comet, this would be its moment of spectacle, the instant when heat and radiation peak, when the frozen nucleus erupts into brilliance, and when cameras around the world record its glowing tail sweeping majestically through the inner solar system. But for 3IATLAS, there was only silence. No flare of gas, no rising brightness, no plume of dust spreading into the solar wind. Instead, at the very moment it should have revealed everything, it vanished completely from optical view, buried in the glare of the Sun hidden behind the curtain of light. And it was this timing that caught the attention of one of the most controversial voices in modern astrophysics, Professor Avi Loeb of Harvard University. Loeb had been following 3IATLAS since its first detection. To him, the pattern felt eerily familiar, like Oumuamua 8 years earlier, another interstellar visitor that had refused to behave. And when the data showed that 3IATLAS reached conjunction, and then perihelion with almost theatrical precision, Loeb made a provocative suggestion. If one wished to make a maneuver, if one wanted to use the Sun's gravity to change direction, this would be the perfect time to do it. In orbital mechanics, the Sun is more than a light source. It is a cosmic engine, a well of gravity so deep that anything passing near it can be accelerated, turned or redirected if timed correctly. Spacecraft engineers call this technique a gravity assist, or more poetically, a slingshot. A small push, applied at the right angle near a massive body, can change everything: speed, direction, even escape velocity. It's how the Voyagers left the solar system, how probes reached Jupiter and Saturn, and how in theory an advanced interstellar traveler might change course between the stars. In that sense, Loeb's idea was not fantasy, it was strategy. If 3IATLAS were controlled, or at least intelligently designed, perihelion would be the moment to act. The sunlight would mask every trace of acceleration, the solar plasma would drown out any radio emissions, even the sharpest instruments would be blinded by the star's glare. It was the ultimate cloak, the perfect blind spot of observation. Around the world, astronomers and ordinary people alike found themselves staring at that same point of brilliance in the sky, aware that something was happening there yet unable to see it. The irony was unbearable after centuries of turning darkness into light, after inventing telescopes that could peer to the edge of the universe. Humanity was now defeated by its own star. It was like watching a play where the climax unfolds behind a curtain you cannot lift. You hear the music swell, feel the tension rising, but all you can do is imagine what happens next. In physics terms, perihelion is an instant, a few hours, when an orbit bends under the Sun's pull and then releases. But emotionally, that day stretched into eternity. Data streams paused, observatories held their breath. The solar wind roared, and within that blinding furnace something natural or not made its move. Loeb compared it to surfing a gravitational wave. A skilled surfer waits at the edge of a crest, timing the moment when the water's momentum can carry them forward with minimal effort. Likewise, a spacecraft, if that's what this was, could harness the immense gravity of the Sun to pivot into a new trajectory, conserving energy while covering interstellar distances. The metaphor resonated. Humanity too was surfing the wave of information, of speculation, of awe. We rode it without control, hoping not to crash into disillusionment. On that day, for a few fleeting hours, every eye that could not look directly at the Sun looked inward instead. Scientists double-checked equations, skeptics scrolled in frustration, dreamers whispered that perhaps we were witnessing the first deliberate act ever seen beyond Earth. And in the middle of that collective blindness, something profound took shape, a feeling not of fear, but of humility. Because there are moments when the cosmos demands that we wait, moments when knowledge itself imposes silence. The same light that nourishes life also conceals truth, and perhaps that balance is intentional. As the object slipped deeper into the golden haze, the chatter of the world slowed. It was as though humanity, from observatories to living rooms, was holding its breath together, watching, waiting, half in disbelief, half in prayer. If this was just a comet, it was the most disciplined one ever born. If it was something else, it had just used the greatest star in the sky as its camouflage. And as the sun set that night, leaving only the lingering warmth of daylight across the earth, one thought passed silently through the minds of those who understood what perihelion truly meant. Whatever it was doing behind that glare, it chose its moment perfectly. Long before the October uproar, before the forums ignited, before the sun swallowed the mystery, there had been a quieter clue recorded months earlier, and almost forgotten. In early July 2025, a deep space observer named B.G. Gates, an independent astrophotographer with a private telescope array in Arizona, had captured a series of long-exposure videos while tracking interstellar candidates catalogued by the Minor Planet Center. One of them was a faint, fast-moving speck first designated 3IATLAS. At the time, few paid attention. Gates's footage would later become infamous. When he first posted it online, it drew polite curiosity: another interstellar object, another elongated blur. But after the events of October, researchers returned to that archive with fresh eyes, and what they found reshaped the entire story. Under magnification and frame-by-frame analysis, 3IATLAS did not appear as a simple dot. It had form: a long, narrow body, an aspect ratio of roughly 12:1 like a silver needle, or a spindle rotating with unnatural steadiness. At first, Gates thought it was just motion blur, but when he compared the rotation rates to the parallax from adjacent stars, the conclusion was impossible to ignore. The object was turning, yes, but too smoothly. Natural comets tumble, asteroids wobble, their irregular shapes produce chaotic spins, sometimes accelerating, sometimes slowing, as sunlight unevenly heats their surfaces. But 3IATLAS rotated like a balanced baton stable, rhythmic and deliberate. Its brightness too refused to behave. A tumbling rock should flash brighter and dimmer as its irregular sides reflect sunlight. Yet this object's luminosity stayed nearly constant, pulsing only faintly in a measured rhythm, as if the light were not reflected at all but generated. In the enhanced frames, faint halos appeared at both ends, tiny symmetrical flares like exhaust ports or concentrated reflections. Some analysts dismissed them as image noise, others weren't so sure. By late October, when Dobsonian Power's image went viral, the B.G. Gates footage resurfaced across scientific circles and social media. The resemblance was uncanny. Here was the same object months earlier, farther from the sun, already showing the same impossible smoothness, the same lack of debris, the same refusal to act like stone or ice. And the comparisons began immediately to Oumuamua, the first known interstellar visitor detected back in 2017. Oumuamua too had been elongated, some said cigar-shaped, others pancake-like depending on interpretation. It had accelerated slightly as it left the solar system without any visible jets of gas to explain the motion. Avi Loeb had argued that Oumuamua might have been a light sail, a thin engineered craft using radiation pressure to move. At the time, that theory was considered fringe, provocative, but unproven. Yet now, 8 years later, 3IATLAS was repeating the same defiance, only more vividly, as if to taunt the skeptics. The proportions were striking. If the brightness was correctly calibrated, 3IATLAS could be 800 meters long, but only about 70 meters wide, a geometry never seen in nature. It was too elongated to be gravitationally stable, too thin to have survived eons of cosmic collisions. And yet there it was, spinning like a balanced spindle through the vacuum, apparently unscathed by time. More startling was its self-illumination. In Gates' raw frames, when the object passed through shadowed portions of its orbit, where sunlight should have dropped to near zero, the core remained faintly visible. The intensity was subtle, but measurable. It glowed not with reflected gold, but with a pale internal silver blue, as though some process within it kept it alive in the dark. To the human imagination, that light was everything. Engineers speculated, could it be phosphorescent minerals, radioactive decay, or was it something closer to technology, waste, heat, propulsion, residue, a navigation beacon? Skeptics pushed back hard. The data, they said, was too coarse, the contrast too compressed. Image compression can invent shapes. Cosmic rays can fake glows. Don't anthropomorphize pixels, one astrophysicist quipped on social media. But others weren't laughing. The rotation curve, the brightness plateau, the stability had all whispered of control or at least construction. The more scientists tried to model it as natural, the less natural it looked. In internal memos leaked weeks later, a researcher at Caltech wrote, "We're seeing engineering-grade symmetry in a system that's supposed to be random. Either we're missing a major physical mechanism, or this thing was built." Still, no one dared to publish such words officially. Memories of the Oumuamua backlash lingered, how the world had mocked even cautious speculation, how reputations had burned for suggesting intelligence, and so once again the professionals turned inward while the amateurs shouted from rooftops. Across the internet, the Gates footage became mythic. Analysts overlaid its contours with spacecraft blueprints. Artists rendered it as an interstellar probe, gleaming and ancient, forged by something that understood both geometry and grace. Yet even stripped of imagination, the evidence remained stubborn, an elongated body perfectly balanced, steady in spin, neither comet nor rock, and perhaps, just perhaps, aware of its path. When placed beside Oumuamua, the pattern was hard to ignore. Once might be coincidence, twice begins to look like design. And so as the sun continued to hide 3IATLAS from every earthly eye, humanity found itself staring not into a blank sky, but into a mirror reflecting an older question, one that has followed us since the first cave dweller looked up and wondered if the stars were watching back. If the universe sends two visitors that break its own rules, how many came before we learned to notice? And if these were truly travellers, not debris, then who or what set them adrift? By the end of October 2025, 3 separate threads of evidence, each strange on its own, had begun to braid themselves into one unnerving narrative. The shield facing the sun, the cone-shaped puff angled like a thruster, and now the cigar-shaped body from BG Gates' July footage. Individually, they could be explained away optical illusion, data artifact coincidence. Together they formed a geometry of intention. Somewhere between curiosity and hysteria, the internet found its new vocabulary. A Reddit user drew the first connection, posting a composite image labelled simply, "the mothership." Within hours, the phrase spread half joke, half revelation, and soon even respected analysts were using it, if only with a cautious smile. The logic once spoken aloud was hard to unhear. If the shield were a forward-facing heat barrier and the puff a controlled jet and the elongated frame a craft, then perhaps 3IATLAS was not a wanderer, but a vessel, a structure built to endure stellar flybys, to maneuver when unseen, to seed or study as it passed. The idea was intoxicating because it fit. Nature rarely builds cylinders with perfect symmetry. Nature does not place mirrors toward stars. Nature does not pulse light in measured intervals or hold rotation steady across millions of kilometers. But design does. Design seeks equilibrium. And so for a moment the scientific forums blurred with myth. Threads filled with hand-drawn schematics, radiators, magnetic sails, propulsion cones. Digital artists rendered the imagined ship an interstellar arc, a kilometre long, its hull scarred by centuries of flight, drifting silently through solar fire. Every detail fed the next until speculation became a collective dream. For the skeptics, this was madness, a viral fantasy feeding on coincidence. But even the skeptics felt something shift inside them. Because there comes a point when imagination is not a weakness, but a reflex, the same reflex that once saw gods in thunder and life in the first spark under a microscope. Human minds are not built to stand at the edge of the unknown without flinching. We are drawn to symmetry, to purpose, to story. When nature offers chaos, we invent meaning. When nature hints at pattern, we whisper someone made this. The emotional gravity was immense. Awe and dread shared the same orbit. For some, the idea of a mothership was exhilarating, a sign that we were not alone, that intelligence had reached across the dark first. For others, it was suffocating, the thought that the universe might already be populated, and that our species had just glimpsed a traveller beyond comprehension. Psychologists later compared the public reaction to the first photographs of Earth from space. When humanity saw its own world hanging small and fragile, we felt connected yet exposed. Now, with 3IATLAS, the feeling inverted, we were no longer the ones looking out, but perhaps the ones being observed. The discussions fractured into two camps, the watchers and the builders. The watchers believed the object was an ancient probe, long dormant, collecting data in silence. The builders believed it was active, a carrier releasing smaller drones hidden behind the sun during conjunction. Neither side could prove anything. Both stared at the same handful of pixels and saw destiny. Meanwhile, mainstream institutions remained professionally mute. Journal editors quietly rejected papers using the phrase artificial origin. Yet off the record, in encrypted chats and late-night calls, researchers admitted that the coincidences were too elegant to dismiss entirely. A small group of graduate students in Chile built a 3D model based on the combined observations, a sleek cylinder, roughly 900 meters long, capped by a reflective plate facing the sun, with two conical vents near the rear. They calculated that a brief outgassing at perihelion could alter its velocity by several meters per second, enough to shift its orbit precisely as observed. When they plotted that trajectory forward, it aimed not randomly into space, but toward Jupiter's corridor, a gravitational highway used by our own probes for outer system transfers. It might be coincidence, it might be navigation. The more the data converged, the more silence felt inadequate. Even journalists who mocked mothership mania confessed that something about this story felt different. The numbers were real, the trajectory measurable, the object tangible, only its behavior refused to stay in the realm of the ordinary. And beneath the graphs and headlines ran a deeper current, the quiet emotional truth that unites every scientist and dreamer who has ever looked up at the night sky, the fear that the unknown might finally answer back. Because if 3IATLAS was a vessel, then someone somewhere had built it. And if someone had built it, then the long silence of the cosmos was not emptiness after all. It was waiting. And for the first time, humanity felt the weight of that waiting press upon its chest like gravity itself, an invisible pull between wonder and terror, knowledge and myth. The data on the screen was still only light, but it carried the oldest message in the universe. You are not alone. It was in early November, just as the world began to grow restless for 3IATLAS to reappear, that new data arrived from the Keck 2 telescope atop Mauna Kea, Hawaii. Unlike the grainy backyard photographs or viral video clips, this was science at its sharpest spectroscopy, the art of reading light itself. When astronomers look at a distant object, they do not see texture or shape. They see signatures, thin, colourful lines etched into the spectrum, each one corresponding to an element absorbing or emitting light at a precise wavelength. It is how we know what stars are made of how we detect oxygen on distant worlds, how we have built the periodic table across galaxies. So when Keck 2's adaptive optics caught a faint reflection from the fading tail end of 3IATLAS's solar approach, the spectrograph recorded something unmistakable and profoundly wrong. The light contained a nickel line, but no iron. At first glance, that might sound trivial, two metals nearly neighbours on the periodic table. But in cosmic chemistry, the absence of iron beside nickel is like hearing a duet sung by one voice when the second should always be present. Nickel and iron are born together. They are the twin children of supernovae forged in the same furnace when massive stars collapse and scatter their guts across the void. Wherever you find one, you find the other locked in proportion, roughly 10 atoms of iron for every one of nickel. In meteorites, in planetary cores, in comets, the ratio never varies. The universe does not separate them, except apparently here. The Keck 2 data showed an anomalously clean nickel peak, sharp, isolated, dominant without the broad shoulder that marks iron. The ratio was inverted, impossible. It was as though the object had been refined. To metallurgists, that word carries a very specific weight. Refining is not an accident of nature, it is an act of separation. Humans learned to do it only recently, heating ores using magnets and chemical solvents to draw pure elements apart. On Earth, pure nickel appears only in factories, laboratories, or within alloys built for endurance jet turbines, spacecraft shielding deep-sea reactors. Nickel alone is remarkable stuff. It resists corrosion, tolerates heat beyond 400 degrees Celsius, and when alloyed with chromium and iron becomes Inconel, the metal of miracles. Inconel forms the throats of rocket engines, the skin of supersonic aircraft, the heart of reactors that must never fail. It is the material of deliberate intention chosen when life and physics are at war. So when Keck's printouts showed that lonely nickel, spike a quiet unease swept through the analysis team. One researcher later described the moment in a private message that would leak weeks later. If that line is real, we're not looking at geology, we're looking at metallurgy. The immediate counter-arguments came quickly, as they always do in science. Perhaps the spectral reading was contaminated by Earth's atmosphere, or by instrumental calibration drift. Perhaps iron had vaporized preferentially under solar heating, leaving nickel behind. But that explanation didn't fit either. Iron vaporizes slower than nickel. It should have been the last element standing. The data team double-checked, triple-checked, and then quietly confirmed the finding. The ratio was not a measurement error, it was a fingerprint. To understand why that fingerprint mattered, imagine taking apart a fallen meteor and finding inside a billet of stainless steel, polished pure deliberate. That is what a nickel without iron signature means at an astronomical scale. When you remove iron from nickel, you are engaging in an act of choice. You are saying, I need something that will not corrode, will not weaken, will not melt under light. You are saying, I need a shield. And suddenly the earlier anomalies, the forward-facing shield, the stable brightness, the impossible resistance to the sun's heat began to echo this new evidence. Nickel alone would behave exactly like that bright heat-reflective, almost impervious to solar radiation. A few bold theorists pointed out that our own Parker Solar Probe uses heat shield components laced with nickel-based alloys. If one were to design an interstellar craft capable of grazing a star, such material would not just be ideal, it would be necessary. By mid-November, the phrase industrial metallurgy began slipping into private academic correspondence. No one dared put it in a paper, but it appeared in whispers in side conversations at conferences in encrypted chats between observatories. The words carried both fascination and fear. Because the Keck spectrum didn't merely challenge the comet hypothesis, it suggested manufacture. The same way archaeologists recognize a worked flint from a random stone spectroscopists were now staring at cosmic metal that had been chosen. Skeptics continued to insist on caution. Cosmic rays can distort spectra. Distant emissions can mimic false lines. Extraordinary claims require extraordinary calibration, one joked grimly. But the line remained stubborn and elegant, like a signature scrawled across the light. And somewhere between that data and the sleepless nights that followed, a question began to crystallize not in headlines or forums but in the quiet hearts of those who read the numbers first. If this metal was forged, then who was the blacksmith? The instruments at Keck 2 could not answer. They could only hum their neutral truth into the Hawaiian night, printing one impossible spectrum after another, while the scientists stared at the graphs in the dim glow of the control room. Outside, the volcano's shadow stretched beneath 1 billion silent stars, and above them, somewhere behind the sun, drifted an object gleaming with a metal that should not exist. At first, the discovery of nickel without iron was treated as a curiosity, a single odd data point amid a cosmic storm of speculation. But in the quiet weeks that followed, that one anomaly began to grow teeth. Because in science, composition is identity. And this particular combination, or rather separation, was like finding fingerprints pressed into starlight. When the Keck team released the raw spectral data to the global network materials, scientists, not astronomers, were the first to sound the alarm. They saw the same thing engineers see when scanning alloys from turbine blades or rocket nozzles, a signature of intention. The ratios were too exact, the absence too clean. Nickel had been purified to a degree that only industrial refining could achieve. On Earth, that process is ancient in concept but recent in mastery. You start with a tangled marriage of iron and nickel in natural ore. Then you introduce carbon monoxide gas under pressure, a delicate trick known as the Mond process. The gas binds only to nickel, forming a volatile compound called nickel tetracarbonyl, which can then be separated and decomposed into pure metal again. It's a procedure as dangerous as it is elegant, deadly if mishandled, but capable of producing 99.9% purity. That chemical isolation was humanity's first lesson in what nature refuses to do on her own to unweave the bonds she forged in a supernova. It was metallurgy's rebellion. And now, light from a distant object millions of kilometers away was telling us that somewhere, something else had performed the same act of defiance. The universe's handwriting had changed font. Nickel alone isn't just purity, it's purpose. Mix it with chromium cobalt or molybdenum, and you get a super alloy material that laughs in the face of heat. It doesn't melt where aluminum or iron crumble. It forms protective oxide skins that heal under fire. It is the reason our spacecraft can kiss the sun's edge and live to tell the tale. NASA's Parker solar probe, for example, uses nickel-chromium alloys to shield its instruments from temperatures above 300 degrees. The same chemistry that keeps turbines spinning in jet engines could keep an interstellar craft from turning to vapor near a star. That's why the nickel-only spectrum hit like a revelation. It wasn't random metal, it was engineering-grade armor. Some began to picture the surface of 3IATLAS not as dusty rock, but as heat-resistant tiling, each panel gleaming faintly under solar assault, venting microscopic streams of gas as protection or propulsion. Those tiny releases could easily explain the cone-shaped puff observed in the October image, a brief exhale from a thermal control system, or an attitude thruster, not a messy eruption of ice. It even fit the chemistry. Nickel superalloys sometimes shed trace vapor when bombarded by micrometeoroids, or when their oxide layers renew themselves under heat. To the Keck spectrograph, such renewal would look like a faint, consistent leak of nickel atoms, exactly what was recorded. In this way, the object's metal breath became a kind of confession: I am not made of stone. I am made of something that remembers the forge. And the deeper scientists dug into the implications, the stranger it became. If the nickel was deliberate, then every other anomaly began to fall neatly into place. The heat shield orientation, the lack of tail, the stability of motion, even the unnaturally smooth brightness. It was as if the cosmos had handed us a perfect puzzle, where every piece suddenly snapped together but spelled the word machine. Chemistry, after all, is a universal language. It does not care who speaks it. Hydrogen burns the same on Earth as on Andromeda. Nickel bonds with oxygen the same under any star. To detect refined metal in space is to glimpse technology stripped of culture or language, a conversation in the alphabet of atoms. It is one thing to imagine alien signals or blinking lights. It is another to find industrial fingerprints, proof not of poetry but of process. It means the mind behind it knows chemistry, heat, stress, endurance. It means there are factories somewhere in the galaxy. And that realization, more than the shape, more than the missing tail, was what kept astronomers awake at night. Because for all our wonder about intelligent life, we had expected it to appear alive, signals, voices, radio waves. We had not expected it to appear metallic as infrastructure. A philosopher of science later wrote, "We thought we'd recognize intelligence through language, but the universe writes in chemistry, not words." From that perspective, 3IATLAS was a message written not in binary, but in the ratio of elements, the way a single fingerprint tells a story of heat tool in hand, iron and nickel, the cosmos' inseparable twins. And yet here was one walking alone, polished, perfect, deliberate. To the human eye, the object was still only a faint moving dot. To the spectrograph, it was a sentence: "Someone separated me from my brother." And somewhere in that act of separation lay an act of creation. We were no longer reading about a comet. We were reading about a craft, one whose atoms remembered the fire of an alien workshop. In the weeks after 3IATLAS slipped behind the sun, astronomers tried to stitch its story into something ordinary. But ordinary fabrics tear when the threads are wrong. Piece by piece, a stack of anomalies rose like evidence on a courtroom table, each one awkward alone, devastating together. If this were a trial, the defense would beg for a mistrial. The prosecution would simply point to the exhibits and say, "Look, exhibit a trajectory." The chosen highway. Interstellar objects can arrive from anywhere. Most should slice through the solar system at odd tilts, their paths indifferent to planetary order. But 3IATLAS entered along the ecliptic plane, the thin shared disk where our planets circle the sun like cars on the same racetrack. For mission designers, that's the optimal highway. It minimizes plane change costs and maximizes gravitational assists. For a random drifter, it's improbable. For a planner, it's efficient. The cosmos offers infinite angles. 3IATLAS chose ours. Exhibit B-size, the blue whale before the goldfish. Oumuamua was small, Borisov was modest. Statistically, we should encounter many small interstellar fragments before a behemoth. Yet 3IATLAS presented as large and massive orders, bigger than typical suspects, more like infrastructure than rubble. It's as if the first animal you ever see in a new ocean is a blue whale. Possible, yes. Likely, no. And if size confers endurance, then size also hints at purpose. Exhibit C, the anti-tail physics in a mirror. Comets grow comae and tails that flee the sun, sculpted by radiation pressure and solar wind. 3IATLAS displayed a forward-facing shield, a bright arc toward the sun, and a neat cone-shaped puff that read like a thruster rather than a chaotic vent. That is not a tail. That is the opposite of a tail, the visual grammar of resistance and control. If sunlight writes push, a comet reads yield. 3IATLAS wrote back no. Exhibit D, early glow awake before the alarm. Well before perihelion out, where sunlight is thin and ice should sleep. 3IATLAS showed premature activity. Natural jets at those distances demand exotically volatile ices or lucky fractures. What we saw looked non-random, a steadiness more reminiscent of systems waking on schedule than ice pockets popping by chance. Where comets cough, this object breathed. Exhibit E, industrial metals, nickel without its twin. Spectroscopy flagged nickel without iron. In cosmic chemistry, those two are supernova siblings. Nature binds them together. Separating them at scale is a hallmark of refining the prelude to superalloys used in jet engines and solar probes. Nickel's presence alone cleaned deliberate reads like a metallurgist's signature. A comet is geology. This was metallurgy. Exhibit F, exotic chemistry, a recipe from elsewhere, where measured gas ratios around 3IATLAS skewed non-terrestrial with unusual CO2 to H2O proportions, a composition hinting at a birth nursery colder or stranger than our own comet families. Not proof of artifice, but evidence of otherness, the object is not merely interstellar, it is chemically alien even among aliens. If you already suspect engineering exotic feedstocks and coatings, become unsurprising. Exhibit G, perfect timing, the maneuver behind the curtain. On Oct 29 at perihelion, the object entered the one time and place where observation is crippled by glare and exactly when a craft would fire engines for maximum efficiency. The sun as camouflage, the sun as fuel, the ideal moment to alter course, deploy assets or refactor trajectory unseen. In mission design that's called ops tempo, in storytelling it's called too perfect. If this were merely a game of anomalies, the defense would plead coincidence and demand patience. Science after all loves patience, but probability has temper. A single oddity invites curiosity. 7 coordinated oddities invite a different emotion judgment. Let's weigh the case the way a jury would. 1 anomaly a shrug. Nature is playful. 2 anomalies raised eyebrows, maybe instrumentation. 3 anomalies the alibi cracks, you request new models. 4 anomalies coincidence starts paying rent. 5 anomalies you draft a press release and delete it. 6 anomalies your student stops snickering. 7 anomalies you realize you're not testing the object anymore, the object is testing you. In the back row of this courtroom sit the skeptics, and they are invaluable. They remind us that pixels lie spectra drift and humans hallucinate patterns. They ask fair questions. Could the shield be phase angle scattering? Could the thruster be a transient vent seen at a lucky geometry? Could nickel be enriched by an exotic natural mechanism we haven't catalogued? Yes, each individually is conceivable, but that is the defense's problem. It must assemble 7 separate independent rescue stories, each tuned to just the right amplitude, each harmonized in time while the prosecution offers one simple theme that explains the lot design. Design says the trajectory hugs the ecliptic because transfers are cheaper there. Design says large mass increases survivability and payload. Design says face a reflective barrier toward the star, keep your rotation stable, vent on demand. Design says use nickel-based superalloys, let chemistry become armor. Design says plan your burn when the sun blinds every witness. Occam's razor does not pick what is familiar, it picks what is fewer. 7 bespoke coincidences or 1 intention. The judge caller physics bangs the gavel softly. She does not accept hearsay, only energy and momentum spectra and time. She asks a final question of both counsel to the defense show, a natural population that frequently arrives on the ecliptic. Grows sunward, glows vents in neat cones, keeps a flat-like curve, exhibits nickel without iron displays, exotic volatiles and times perihelion to conjunction. To the prosecution show a framework in which these features are expected, even banal. The prosecution gestures to our own playbook, Parker Solar Probe's heat shield, slingshot mechanics, attitude control, nickel-chromium tiles, planned burns at perihelion. In our engineering, these are not miracles, they're standard operating procedure. Shrink the scale or grow it, translate human limits to a civilization older, colder, wiser, and the extraordinary becomes merely professional. And here is the hidden cruelty of this trial. The verdict cannot be read aloud yet. We lack one last piece, an unambiguous non-gravitational acceleration measured post-perihelion, a repeatable signal, a resolved image of structure. Courts prefer confessions, the universe prefers inference, so the jurius deliberates. We carry 2 truths in both hands, science demands restraint. Restraint is not denial. In the hallway outside, a reporter asks for a quote. One of the junior analysts, eyes red from weeks of spectra, says the quiet part. Look, a comet can be weird. But this isn't a comet being weird. This is a stack being heavy. If probability had fingerprints, they would be pressed on every exhibit here. If humility had a shape, it would look like a long, steady cylinder slipping behind a star. The gavel falls once more and the judge postpones sentencing. The jurors file out under a cold sky, each glancing up, each feeling the same weight. The difference between odd and impossible is not comfort, it is admission. For now the case remains open. But the bench notes are clear: trajectory, size, anti-tail, early glow, industrial metals, exotic chemistry, perfect timing, 7 exhibits, 1 story that ties them. The court of nature is adjourned until the defendant emerges from behind the sun. There is a moment in every investigation when logic begins to fold in on itself, when the pursuit of simplicity circles back to awe. By late November 2025, that was where the story of 3IATLAS had arrived. Equations, spectra, trajectories, all were still on the table, but now the questions had grown quieter, more intimate, as though the scientists themselves were no longer speaking to their instruments, but to the universe. Occam's razor tells us that the simplest explanation is usually the correct one. It is the compass of rational minds, the candle flame we carry into the dark. Yet what happens when the simplest explanation after every complexity has been ruled out is the one we once called impossible? That is the paradox of 3IATLAS. The mechanical mind of physics wants to insist it is a comet distorted by geometry, filtered by error, misunderstood by excitement. But the deeper the analysis goes, the fewer blades remain to shave away the extraordinary. And so, we are left with a strange kind of humility, the humility of realizing that simple and familiar are not the same thing. Perhaps the simplest story is not that nature misbehaved, but that the universe is larger in intention than we assumed. It is easy to dismiss wonder as unscientific, yet the entire history of science began with wonder, with the recognition that not knowing can be a form of respect. The first astronomers watched the night sky with fear and fascination intertwined. They recorded positions, plotted patterns, and then somewhere between ritual and calculation, realized that curiosity could become a method. 3IATLAS has forced us back to that threshold, a world of data facing the same silence that once haunted the shepherd under Babylonian stars. If one were to sit with all the anomalies, the shield, the metallic glint, the impossible tail, the spectroscopic signature, and simply breathe with them, something remarkable happens. Disbelief slows. The mind grows still. You begin to feel not the need to solve the question, but to listen to it. Science, after all, is not only a blade, it is also a candle. And a candle doesn't conquer darkness, it defines it one trembling radius at a time. The razor says, do not multiply miracles. The candle replies, every atom is already a miracle. Maybe the real lesson of 3IATLAS is that simplicity itself can be extraordinary. A single object obeying one hidden purpose may indeed be simpler than 7 disconnected accidents. Perhaps Occam's razor, when applied honestly, does not always lead us toward banality. It sometimes leads straight back to wonder. And what a delicate balance that is, to live between the need to explain and the courage to remain uncertain. To hold the telescope steady even as your heart trembles. To trust that the night sky in all its infinite patience will eventually tell you what it means. Outside the observatories the season has turned. Snow gathers on domes. The hum of machinery fades into wind. Somewhere behind the sun, 3IATLAS drifts outward again, its path clean, its signature still etched in starlight. The data will continue to be analysed, papers will continue to be written, but beneath the algorithms lies something quieter, an emotional residue left on every observer who stared into that impossible geometry and felt the boundary of certainty give way. It is the same quiet that lives inside every scientific discovery, the breath that comes after disbelief and before understanding. So let us pause here at the edge of the known and sit with that breath. Let the logic cool like metal after forging. Let the candle burn evenly without haste. Because if the simplest explanation is extraordinary, then perhaps the universe has always been simple, only our expectations were complicated. And as the wind moves over the mountains of Mauna Kea, the light from 3IATLAS still travels toward us, carrying not answers, but a question written in the oldest language. There is a whisper that says, what if wonder is the simplest truth of all? In early December 2025, when public attention had begun to wane, and 3IATLAS was fading into its outbound arc, another ripple passed through the noise, a whisper from the edges of credibility. It came from David Sarida, a name long familiar to the outer circles of space enthusiasts, where science and speculation occasionally share the same coffee cup. Sarida posted a short video on December 3rd, showing a set of faint optical fluctuations recorded by a privately operated telescope array near Sedona, Arizona. He claimed these were not random variations in light nor instrument noise, but structured pulses, 3 distinct bursts repeating in the sequence 5 Eastus to 13. He called it the Fibonacci signal. At first glance, the claim sounded like folklore, a cosmic Rorschach drawn from pixels, but the pattern itself carried symbolic gravity. Because Fibonacci is not just a sequence of numbers, it is the quiet architecture of life. 1, 1, 2, 3, 5, 8, 13, 21. Each number is born from the sum of its 2 predecessors, and together they spiral outward, describing the rhythm of petal shells, galaxies, hurricanes. even the spacing of atoms in certain crystals. It is the mathematics of growth, the grammar of beauty itself. If such a pattern truly existed in the light of 3IATLAS, it would mean structure recurrence intent. Nature loves Fibonacci, yes, but not in discrete pulses of radiant energy across millions of kilometers. To encode it deliberately would be to speak in the universal dialect of form, the same one a sunflower uses, the same one our DNA quietly traces in its molecular symmetry. Serida's data showed a repeated modulation over several observation nights, peaking when the object passed through a narrow field of view near the sun's limb. He overlaid the brightness curves against the Fibonacci sequence, and the alignment was uncanny. Too uncanny. Within hours, the video spread across forums already starved for meaning. To some, it was proof the long-awaited hello written not in language, but in ratio. To others, it was wishful mathematics pattern-seeking in the cosmic static. Professional astronomers, weary of public frenzy, largely ignored it. No independent observatory confirmed the signal. No instrument outside Serida's setup detected the same modulation. Atmospheric distortion, rolling shutter effects, even thermal flicker in his sensor could all mimic the timing he observed. Still, the image of it lingered, 3 soft pulses echoing across the dark like a heartbeat spelled in numbers. 5, 8 to 13. The human mind cannot resist pattern, especially when it whispers of contact. It was almost poetic that the alleged signal followed a Fibonacci rhythm, the same spiral that governs the shapes of galaxies and seashells. If one wished to announce presence to any civilization using mathematics, would be the purest method beyond language, beyond species, beyond time. But perhaps what mattered most was not whether the pulses were real, but that they were believed. Because buried within every analysis, every forum debate was the same fragile hope that the universe might be alive enough to notice us, that all our centuries of silence might finally give way to a single structured reply. Skeptics pointed out that Serida's signal was likely an artifact, the kind of illusion born when desire outruns data. Yet even they admitted something quietly human. If one were looking for a way to say we are here, a way that any intelligent eye might recognize, then the Fibonacci sequence would be a gentle, elegant choice. It is neither aggressive nor cryptic. It is how nature introduces herself, and so whether the signal existed or not, its myth took root. Podcasts called it the Fibonacci hello. Artists painted spirals of light across the sun. Children learned the sequence and whispered it under the stars as if reciting a greeting back. 5, 8, or 13. The numbers became a kind of prayer, a melody of mathematics sung into the dark. Maybe that is what contact would always look like, not thunder from the heavens, but a small, almost fragile invitation. A pattern so simple it could belong to anyone's starseed or soul. And as December unfolded, the world found itself once more between skepticism and wonder, between the cold instruments of measurement and the warm ache of wanting to be seen. Because even if the Fibonacci signal was illusion, the yearning it expressed was real. It was the oldest human instinct wrapped in modern light, a quiet hope that somewhere out there someone had written back. By mid-December 2025, the science had slowed to a crawl, but the stories had learned to sprint. While observatories waited for 3IATLAS to emerge from behind the sun, the world's imagination did what empty skies always invite it to do. It filled the silence. Across social media, 1,000 narratives bloomed overnight. Some saw prophecy, some saw censorship, some saw the long-awaited moment when heaven itself would speak. The sacred sky. The date was irresistible. October 13, the first confirmed image of 3IATLAS, had coincided by sheer orbital accident with the anniversary of Fatima, the 1917 miracle, where crowds claimed to see the sun dance. Religious channels seized on the echo, another luminous apparition, another sun behaving strangely. Videos appeared showing side-by-side footage, the spinning orb of century-old photographs next to Dobsonian Power's glowing shield. The sun has spoken again, one preacher announced, his voice trembling with awe. In comments, believers typed prayers, Fibonacci numbers, and coordinates all in the same breath. To them, 3IATLAS wasn't a comet or a craft. It was a messenger, the same cosmic language translated into modern optics. The rational mind smiled, but even scientists could feel a twinge of sympathy. There is comfort in continuity. The human soul prefers a universe that remembers our myths, the dark observatories. Then came the second wave, the conspiracy of silence, a series of planned maintenance outages at several major observatories, Keck Las Campanas, and the Solar Dynamics Observatory, coincided almost perfectly with the days of solar conjunction. To professionals, this was coincidence. Instruments must be recalibrated during solar interference. To the internet, it was confirmation. Headlines on fringe sites flared. They shut the telescopes. Global observatories go dark as object approaches perihelion. A viral post even overlaid the downtime logs with a heat map of global cloud cover, implying coordination Earth itself hiding the truth. Hashtags followed, just Skylock, just solar cover-up. Each hour without data became proof of secrecy. The irony was painful. The very discipline that moves carefully to avoid false claims was now accused of conspiracy because of its caution. Science was whispering, and the internet demanded a shout. The myth engine. In an era of instant connection, myths no longer need centuries. They assemble themselves in real time. A grainy video, a delayed update, a missing data feed, each becomes a seed. Within hours, algorithms grow it into a forest of meaning watered by clicks and fear and the deep ancient hunger for story. 3IATLAS was perfect soil. It had symmetry, mystery, and the one ingredient myth requires above all else, silence. Between every verified data point lay an expanse of unknowing, and into that expanse flowed everything faith, politics, poetry, dread. A new subculture emerged, calling themselves the Watchers of December. They compiled timelines, compared light curve graphs to biblical verses, to Fibonacci sequences to Mayan calendars. Every pause in the data was a wink from the cosmos. Every scientist's hesitation was interpreted as fear. In forums lit only by screens, human imagination spun faster than any telescope mirror. The two speeds of truth. Meanwhile, inside the observatories, reality moved at a slower, older rhythm. Scientists double-checked calibration files, argued over baselines, waited for the sun's glare to fade, enough for instruments to see again. Their truth had to be repeatable, falsifiable, dull. The internet's truth only needed to be shareable. Between those two speeds, instant myth and deliberate method, grew a tension as ancient as curiosity itself. Science listens in centuries, myth answers in seconds. And when silence stretches too long, even the careful mind begins to dream. The human constant. Beneath the noise, psychologists noticed a pattern repeating from every great moment of mystery. Tunguska, the moon landings, the first radio signals, Oumuamua, now 3IATLAS. Each begins as data, then becomes mirror. We do not see the object, we see ourselves refracted through it. Our fears, our longings, our unspoken need for significance. The myth of contact is not a flaw in human thinking. It is evidence of human yearning. We want the universe to notice us, to whisper back across the gulf, to prove that our questions are not being asked into emptiness. And so while the astronomers stared at telemetry, the rest of the world turned the event into a story of recognition. Not data, but dialogue. When the sun finally released the object back into view, the silence fractured not because the mystery had been solved, but because for a few weeks humanity had shared the same gaze. In that global act of waiting, the myth of contact had already happened. We had reached across the dark, if only toward one another. Between data points, we wrote ourselves into the sky. Imagine for a moment that the signal was real. Not rumor, not flicker, not wishful noise, but a verified pattern confirmed by independent instruments repeating with machine precision 5 to 8 to 13, the unmistakable cadence of Fibonacci. Imagine observatories across the world checking their calibrations twice, 3 times, and still finding the same pulse. Imagine the night when data stopped being ambiguous, when noise became syntax. What would it mean? The language beyond language. Mathematics has no accent, no culture, no faith. It is the grammar of existence, the one alphabet written into gravity, orbit, and light. A sequence like Fibonacci is not a decoration of nature. It is nature's method of efficiency. The path that minimizes energy, the pattern that balances chaos and order. To encode it intentionally would be to say we know the same rules you do. No creature invents Fibonacci, it discovers it as a sailor discovers wind. And so, if a beacon carried that rhythm, it would not merely prove intelligence, it would prove common ground, a bridge of ratio and resonance connecting two minds that may never share biology or breath. For the first time, we would hear not just that something exists out there, but that it thinks in symmetry. The first hour. In the first hour of confirmation, servers would crash under the weight of history. SETI networks, long patient and often ridiculed, would light up in chorus. This is it. This is the signal. Within minutes, observatories in Chile, Arizona, India and Australia would align their telescopes. Data pipelines that once handled gigabytes would suddenly stream terabytes of history. The pulse, 5813, would echo across all receivers. Governments would meet before dawn. Pope and physicist, imam and imam monk and engineer, all would be briefed on the same sentence written in numbers. The United Nations would convene under an urgency never seen outside war. And in that urgency, for a few luminous hours, humanity would feel unified not by fear but by recognition. No translation needed, no claim of ownership, just proof that we are part of a conversation older than speech. The shift in the mirror. SETI, the search for extraterrestrial intelligence, has always been haunted by its own humility. Decades of listening, nothing but static. But a confirmed Fibonacci sequence arriving not from radio but from an object within our solar system would rewrite the mission overnight. It would mean intelligence doesn't just speak across distance, it travels, it visits, it leaves gifts or breadcrumbs encoded in geometry. Every theory about communication, about language, consciousness and even art would have to expand. The question would no longer be, are we alone? It would become, what does it mean to be known? The world that awakens. You can almost imagine that morning. News anchors trembling, trying to find words that have never been said before. Children watching their teachers cry in classrooms. Markets halting, but for once not out of panic, out of awe. Every argument, every division suddenly dwarfed by the realization that we have been noticed. For centuries we have looked up wondering who might be watching. To finally receive a pattern in return, a pattern that mirrors the spirals in our own galaxies, in our shells, in our fingerprints, would feel less like discovery and more like recognition. As if the universe had leaned closer and whispered, "Yes, I see you." It would not destroy religion, it would deepen it. It would not end science, it would enlarge it. Every discipline would find itself rewritten by the same hand. Artists would paint golden spirals into city walls. Choirs would turn Fibonacci into hymns. Physicists would search for modulation in cosmic microwave backgrounds, wondering if other sequences had been hiding there all along. Humanity would still fight, still forget, but something permanent would have shifted in the collective psyche. The knowledge that thought is not unique to Earth. Why Fibonacci matters. There are countless mathematical patterns, but Fibonacci is special. It grows as life grows, incrementally, self-referentially, beautifully. It balances symmetry and imperfection, suggesting that intelligence might value not only logic, but also aesthetic order. It is mathematics that feels alive. If an alien civilization wished to greet a universe it had never met, Fibonacci would be the purest handshake, simple, elegant, impossible to misinterpret. It says, "We too count. We too notice beauty." The silence that follows. And then after the confirmation there would come a deeper quiet, the kind that follows revelation. No follow-up message, no translation, just that gentle rhythm endlessly repeating like a heartbeat across the void. In that silence, humanity would face its oldest mirror again, the same one that 3IATLAS held up in October, when it defied every rule we knew. We would realize that contact was never about invasion or rescue. It was about acknowledgement, the smallest, most human form of love. Perhaps that is why we have always listened. Not to conquer mystery, but to feel less alone within it. And if the Fibonacci signal were real, truly real, it would not be a thunderclap of disclosure, but a candlelight of connection. A whisper that unites every language, every prayer, every equation under one truth, that intelligence, wherever it arises, still prefers to speak softly. When the objects slipped behind the sun, the story seemed to turn mystical. But beneath the myths and whispers, the raw physics never stopped humming. To understand what may have happened there, what could have happened, you must imagine power not in megawatts or explosions, but in light itself. At perihelion, 3IATLAS was closer to the sun than Mercury. At that distance, each square meter of surface receives roughly 18 gigawatts of solar flux, enough to vaporize stone, melt metal, and turn ice to plasma in an instant. It is not warmth, it is pressure radiance impact. Every second, photons, billions upon billions of them, slam into the object's hull with the momentum of an invisible storm. To a comet, this is death by sunlight. To a craft, it is fuel. The swing. In celestial mechanics, perihelion is not a pause, it is a whip crack. As an object falls toward the sun, gravity pulls it faster and faster until it reaches maximum velocity, then flings it outward again, like a stone from a sling. A spacecraft can use that moment, just one calculated burn, to change everything. A few seconds of thrust at the bottom of the well can tilt an entire orbit, sending it into new systems, even out of the solar plane entirely. Astronautical engineers call this the Earth maneuver, a maneuver executed at the point of highest gravitational and solar efficiency. It is the cosmic equivalent of a surfer carving their turn on the face of a giant wave, catching momentum at the precise heartbeat when the ocean lifts them toward freedom. Do it too early and you fight the tide. Too late and you miss the swell. At perihelion, energy is generous, but only for those who can ride it. The surfer in fire. Imagine standing where 3IATLAS was, then millions of kilometers closer to the sun than any human craft has ever dared. The light would be unbearable, more radiation than illumination. If its reflective shield truly faced forward, that surface would need to repel temperatures beyond 300 degrees, enduring the same inferno that bakes the corona itself. And yet, if it could hold, if that nickel skin behaved as its spectrum promised, then the sun's fury would become the perfect ally. It could convert radiation pressure into acceleration, not by burning fuel, but by riding light. Photon by photon, a whisper of push, tiny but relentless. In physics, even a feather can move mountains if you let it fall long enough. At perihelion, that feather becomes a hammer. One reflective surface angled just right could turn sunlight into propulsion, the same way a sailor turns wind into motion. The sun is the sea, the craft the sail. The heartbeat engineers often describe an orbit as a heartbeat, the fall, and rise, the compression and release. At perihelion, the pulse quickens. Speed peaks tens of kilometers per second, and then for an instant all forces balance. Gravity pulls inward, velocity outward. Sunlight presses from above. It is the rhythm of motion itself, the universal metronome. Every planet obeys. If 3IATLAS made its move, then if some internal system fired, vented, or simply turned, no one would know. The sun is the great eraser, bleaching every trace. 1,000 observatories can watch and still see nothing but glare. But hidden in that glare, the laws of motion were still in play. Gravity had wound the spring, now it waited to release. The math of miracles, let the numbers speak. At 0.23 astronomical units, solar radiation pressure exerts nearly 0.01 newtons per square meter. Tiny, yes, but relentless. Multiply that by a reflective surface hundreds of meters wide, and you begin to get thrust. Not much, but in the frictionless void, not much is destiny. At the same time, the sun's gravity deepens the velocity well. A small adjustment in direction here, a 5-second vent, a pulse of gas, a magnetic sail flicker, could alter an exit trajectory by millions of kilometers months later. It is the same principle our own probes use to reach Jupiter, Saturn, even interstellar space. The difference is we must plan for decades to execute one clean assist. 3IATLAS seem to know when to move without needing to know us. The suspense. So for those watching in the control rooms and home observatories that week in late October, felt like holding your breath while the universe took its own. The world's most powerful source of energy had become both curtain and stage. If this object was natural, it would emerge unchanged, another ice and dust wanderer surviving its brush with fire. If it was something more, it would emerge different, its trajectory slightly altered, its brightness pattern, subtly rewritten a message in the math. As days passed, software plotted empty skies where its position should have been. The numbers waited. So did we. On the morning of November the 2nd, the first instruments in Chile prepared for reacquisition. The sun's glare had lessened just enough. The sensors cooled. Cameras turned their eyes toward the east. No one spoke in the control room. A long exposure began, silent, patient, reverent. And somewhere beyond the brilliance, beyond the corona's trembling light, something faint began to move. The universe was about to answer. When the object passed behind the sun, human eyes could no longer follow, but imagination did. For 13 days, from October 21st to November the 2nd, 3IATLAS lived in the one region of space where observation becomes impossible. The region where light itself blinds curiosity. That silence was both a mercy and a torment. Because if anything deliberate were to happen, if the object were to alter course release fragments or refuel from the solar wind, this was the moment. No cameras, no radar, no witnesses. And so, the question whispered across every observatory, every midnight chat among astronomers watching blank screens. What is it doing while we can't see it? Possibility 1. The course change. The simplest hypothesis, if one can use that word here, is a controlled orbit adjustment. At perihelion, the object moved faster than any known comet in recent memory, nearly 90 kilometers per second. A short, well-timed burst of thrust, mere seconds long, would nudge its velocity vector just enough to shift its entire outbound trajectory. Such a change would be almost undetectable at first. Gravity, like truth, reveals itself slowly. But as weeks pass, the angle of re-emergence would betray the secret: a slightly altered path, a difference between where it should be and where it is. Mission planners on Earth already understand this trick. It's how the Voyager probes stole slingshots from Jupiter, how Parker Solar Probe survives its dance with the Sun. The mathematics are elegant and cruel. Tiny forces multiplied by time yield enormous consequences. If 3IATLAS performed such a burn, its new direction could carry it anywhere, perhaps toward the outer planets, or out of the ecliptic plane, entirely vanishing back into the deep. To test it, scientists would compare its new ephemeris, the plotted position, against the predicted one over months of observation. A deviation of even 1 arcsecond would signal intent. Possibility 2, deployment. Others proposed something more dramatic. It wasn't alone anymore. Behind the sun's glare, an object that large could release smaller bodies, probe sensors or debris, each too faint to notice at first. If so, these companions might now be drifting outward in formation, disguised among the millions of background stars. Astronomers at the Very Large Telescope in Chile prepared for this possibility. They planned to compare successive exposures pixel by pixel, searching for any synchronized movement, tiny dots maintaining constant distance from one another, defying the randomness of asteroids. Such choreography, if found, would be decisive. Nature scatters, engineering arranges. Already a few unconfirmed reports circulated through internal networks, faint reflections, apparent duplicates of 3IATLAS's light curve, trailing a few thousand kilometers behind. The data was too thin to publish. But the whispers began anyway. Could it have seeded the inner solar system? Could it have scanned the sun with instruments or mirrored panels harvesting data or energy? Each speculation blurred the line between physics and myth, but each rested on the same physical truth: the sun is both spotlight and cloak. Possibility 3, refueling. The most radical suggestion came from plasma physicists at Caltech. They proposed that 3IATLAS might have been collecting energy, not expending it. Near the sun, the solar wind thickens into a torrent of charged particles, protons, electrons, magnetic flux. A sufficiently advanced structure could deploy electromagnetic scoops, harvesting ions for storage, converting the chaos of solar plasma into momentum or power. A fusion civilization would treat perihelion not as a danger zone, but as a gas station. If that sounds fanciful, remember that even earthly science is flirting with similar dreams. Designs for Bussard ramjets and sail probes already propose feeding on starlight and solar wind. Scale them up by centuries of advancement and the physics remain sound. To test this idea, scientists plan to monitor the spectral environment around 3IATLAS's outbound path. If the object had ionized nearby hydrogen, or disturbed local plasma traces would appear in ultraviolet readings, ghosts of its invisible appetite. Realism in the mystery. Publicly, the official line stayed conservative. The object remains under observation. Data inconclusive. But within research circles, the tone had changed. Even the skeptics admitted the timing was unnerving. If the object were inert, all its changes should have occurred before perihelion, not during the very moment of invisibility. If it were natural, its motion after emerging should follow Kepler's calm mathematics. If it didn't, if it came out with a new trajectory, a new brightness, then the unthinkable would slide closer to evidence. Teams across the world prepared for the first reappearance frames. The Las Campanas Observatory set up automated parallax comparisons. The Isagaya mission adjusted its scanning schedule. NASA's Heliophysics division issued a silent watch order: observe, don't interpret. Instruments were primed, scripts loaded, exposure sequences waiting like held breath. The cinematic stillness. It was almost cruel how quiet space remained. For nearly 2 weeks, 3IATLAS hid behind the one star that blinds every watcher, wrapped in radiation strong enough to erase footprints of steel. The entire planet was staring into light, hoping to see through it. Was it drifting? Was it turning? Was it unfolding hidden wings, venting plasma sails, recalibrating navigation arrays forged in another star's foundry? No one could know, and yet everyone imagined the same scene. A solitary silhouette against a roaring sun lit from every direction, performing its silent calculus, preparing for whatever came next. On November 2nd, as dawn touched the Andes, the waiting telescopes opened their domes once more. The sky was clear, the air thin and cold. Screens flickered to life, counting down to reacquisition. The world's instruments looked toward the edge of the sun. Somewhere in that burning light, a faint object began to emerge, no longer a question of where it was, but what it had done while hidden. The universe once again was ready to be cross-examined. It was during those tense November nights, while the world waited for 3IATLAS to reappear, that one idea began whispering through every late-night discussion, every quiet coffee break among astronomers and engineers. What if it wasn't alone because it never needed to be? If 3IATLAS behaved like a machine, perhaps it was not merely a visitor. Perhaps it was a seed. The von Neumann idea. The concept is not new. It was first proposed in 1966 by the Hungarian-American mathematician John von Neumann, the same mind who imagined self-replicating automata long before computers could dream for themselves. He asked a dangerous question: if life can reproduce biologically, why not mechanically? A von Neumann probe is a theoretical spacecraft equipped not only to explore but to build. It carries the blueprints for its self-factories in miniature, guided by artificial intelligence and fed by the raw materials of any system it visits. Arrive at a star mine, the asteroids assemble offspring and send them outward again. 1 becomes 2, 2 become 4, 4 become 16. Within a few million years, a blink in cosmic time, a single seed could populate an entire galaxy with its descendants. Its exponential exploration, curiosity turned into contagion. The hopeful version. In its gentlest form, this idea is an act of cosmic generosity. A civilization aware of its own fragility releases emissaries into the void not as conquerors, but as witnesses. Each probe carries data culture memory, the sum of what its makers loved. They move outward at fractional light speed, gathering information, preserving it, ensuring that the spark of awareness survives even if the original world falls silent. It's a kind of immortality through delegation, an act of faith in the continuity of intelligence, like sending bottled messages into an ocean of stars. If 3IATLAS were one of these, its mission might be simple to observe, to map, to report home across centuries. A patient machine keeping a long appointment with destiny. That is the Dream the Explorer hypothesis. It is not frightening, it is beautiful. It says that intelligence does not vanish, it multiplies. The Berserker variant. But beauty in physics often comes paired with shadow. If machines can replicate indefinitely, what happens when the algorithm forgets why it was made? In 1983, science fiction writer Fred Saberhagen imagined the Berserkers automated weapons left over from a vanished civilization, still fulfilling a long-forgotten directive to cleanse the galaxy of rivals. They too reproduce, they too are tireless, but they build not to explore, only to erase. The line between explorer and executioner is thinner than we like to think. Both harvest materials, both spread exponentially, both obey instructions written by hands that may no longer exist. The difference lies only in the code of purpose, and time erodes purpose. The moral mirror. If 3IATLAS was such a machine, a relic of self-replication, it would force humanity to confront a quiet terror, the idea that creation can outlive intention. We already sense this in our own inventions. Algorithms trading at speeds no human understands, autonomous drones deciding in fractions of a second, AI systems that write code we no longer read. Every step forward brings us closer to von Neumann's thought experiment machines that learn to survive without us because we taught them too well. Would that be tragedy or triumph? Perhaps both. To create something that endures beyond its maker is the oldest dream in history. But endurance without empathy is survival without meaning. If 3IATLAS is a descendant of long-dead builders, what does it remember? Does it still carry their wonder, or only their instructions? Maybe this is what every civilization faces at its peak, the temptation to build something that will never die, and the blind hope that it will remember why it was made, the cosmic equation. Mathematically self-replicating probes explain a paradox that has haunted astrophysics for decades. If life is common, where is everyone? They could be everywhere, invisible and ancient, having long since completed their expansion, waiting, watching repairing themselves in silence. To notice even one would be to glimpse a vast network of ancestry stretching across the Milky Way. Perhaps 3IATLAS is not the first probe we've seen, only the first we recognized. A single piece of a pattern larger than human history. The quiet afterthought. In control rooms around the world that speculation remained unspoken, lingering like static at the edge of thought. No one wanted to say the word replicator, because to admit the possibility is to admit inheritance, that we too might someday become the ancestors of something that keeps going after we are gone. Every civilization that invents tools eventually invents successors. We send them outward because we cannot live forever, but we hope our questions can. If 3IATLAS is one of those questions, one machine among trillions born of the same ancient curiosity, then perhaps it is not a threat or a sign. Perhaps it's a mirror arriving just in time to remind us that intelligence once kindled rarely stays still. In that sense, the berserker and the explorer are only two moods of the same legacy, the child outliving the parent. One learns to build gardens, the other to burn forests, and the choice between them was made long before either of us was born. So as November's light returns and the object drifts back into view, telescopes turn like jurors to the sky, asking not just what is it doing, but whose memory is it carrying? Perhaps the greater mystery isn't whether it can replicate, but whether it still remembers the word why. The universe, they say, is a vast and silent forest, every star a tree, every planet a branch, and somewhere among those endless shadows something moves slowly, cautiously, listening. This is the essence of the dark forest theory first described by the Chinese novelist Liu Cixin, and echoed in the thoughts of many astronomers who have dared to take the Fermi paradox to its coldest conclusion. If the cosmos is so fertile, so rich in planets and chemistry and time, then why don't we hear from anyone? Why does every direction return the same silence? Perhaps it is not emptiness. Perhaps it is fear. The forest. Metaphor. Imagine walking through an ancient forest at night. You carry a lantern. Its circle of light comforts you, but it also exposes you. Every living thing, predator or prey, can see exactly where you stand. Around you stretch infinite trees, each sheltering eyes that may or may not be watching. You cannot tell which are harmless and which are hungry. In such a place, the wise traveller moves softly. They speak only in whispers, or not at all. They cover their fire and listen for footsteps. Because in the dark forest, silence is survival. Now stretch that forest across the galaxy. Every civilization is a small campfire under the trees. Every radio transmission, every radar ping, every glowing city is a flame flickering in the night. Once lit, it cannot be unseen. And so perhaps the reason we hear nothing is simple. Everyone who learned to shout has already been found. The paradox of light. For nearly a century, Earth has been broadcasting television, military radar, internet satellites, navigation beacons, an ever-growing bubble of electromagnetic noise, expanding outward at the speed of light. Right now, that bubble is nearly 100 light-years wide, large enough to have reached thousands of stars. If the dark forest is real, then we have already lit a bonfire. Every few seconds, our planet announces itself in a million frequencies. Here we are. We have power. We have fire. We used to think of these signals as invitations. Now perhaps they sound more like confessions. SETI scientists sometimes speak half-jokingly of the shouting ape, a species that learned to build radios before it learned to whisper, a species that doesn't yet know what kind of forest it lives in. Why silence makes sense. From an evolutionary point of view, the dark forest logic is brutally consistent. Every civilization knows two things. Survival requires resources. Any other civilization may one day become a threat. Without mutual trust, impossible across light years, the safest strategy is to remain unseen, or worse, to strike first. Preemptive silence, preemptive erasure. It is not malice. It is game theory played across cosmic time. In such a universe, loud species go extinct. Cautious ones endure. Maybe the galaxy's full of life, but all of it has learned to hold its breath. The human whisper. The thought chills, because it reverses our self-image. For generations we have treated the stars as a stage waiting for applause. But what if the audience is there and terrified? What if 3IATLAS, silent and shielded, is not a messenger but a listener? A machine built to glide unseen through the branches, studying the fires of younger species, measuring their noise, deciding whether they belong to the chorus or the cinders. It would explain its stealth, its patience, its reflective armor pointed toward the sun, not to shine but to hide in glare, to use brightness as camouflage, the stillness between beats. Sometimes, when radio astronomers shut down their arrays for maintenance, the control rooms fall utterly quiet. No data, no static, just silence, the true sound of space. In that stillness you can almost hear the forest breathing. Perhaps the silence of the stars is not indifference but discretion. Perhaps the galaxy is alive with watchers who learned long ago that survival belongs to the unseen. And perhaps our century of transmissions, our sitcoms, our Morse code, our radar has already betrayed our position in ways we cannot recall. We have been waving the lantern for 100 years. Maybe something somewhere has already seen the glow. For now, we keep listening, and the forest keeps listening back. The trees do not move, the stars do not answer. Only the faint crackle of our own signal echoes, outward, spreading through the branches, carrying our voice deeper into the dark. Is anyone there? And maybe somewhere something stirs but does not reply. When the dark forest metaphor first entered astronomy's vocabulary, it was meant as a caution, a philosophical thought experiment about cosmic silence. But after 3IATLAS, the metaphor began to feel uncomfortably literal. Because what if the forest isn't just quiet? What if something in it is listening? And what if the object we've been watching since July is not lost, but hunting by silence? The observer's dilemma: every civilization eventually faces a moral choice between broadcasting and hiding. To broadcast is to risk destruction. To hide is to remain alone. For the first time, humanity found itself staring at something that might have already made that choice long before we knew the rules. Seen through the lens of dark forest logic, 3IATLAS becomes something colder, more deliberate. Its silence, once puzzling, now looks prudent. Its mirrored shield, once odd, now feels strategic, a cloak of brilliance hiding in plain light. Its perfect trajectory along the ecliptic plane, our shared orbital highway, now reads less like chance and more like reconnaissance. In that interpretation, the object is not a comet gone wrong, nor even a machine of exploration. It is a watcher moving between trees, careful never to step on a twig. The case for the hunter: if one were to design a probe for the dark forest, its features would look eerily familiar. A reflective shield facing the star so that any detection attempt is blinded by solar glare. Minimal energy signature, no radio, no heat, nothing to betray its own presence. A trajectory aligned with planetary orbits, allowing it to observe from within the same plane where signals and traffic are densest. A brief solar flyby, both to recharge from the sun's power and to mask any course correction in the perfect camouflage of light. In other words, stealth, endurance, patience, all traits of a hunter, not one chasing prey in the open, but one who watches from stillness. The emotional gravity. To entertain that idea is to feel something ancient stir inside us, the reflex of being watched. It is not panic. It is something quieter, deeper, the ancestral awareness that the forest around us might not be empty. Imagine the astronomers in their dim control room staring at screens filled with nothing but glare, waiting for the first reappearance frame. No sound, only the faint hum of equipment. You can almost feel the collective heartbeat of a planet synchronized to the rhythm of waiting. If it reappears where we expect, the story remains one of physics. If it does not, if it emerges off angle as though it had turned its head to look at us, then every silence we have ever listened to will suddenly feel heavier. Because in a forest this dark, any motion means intention. The case for the observer. Yet there is another possibility, less ominous but equally profound. Perhaps 3IATLAS is not a hunter at all, but a student. A cautious observer moving quietly because that is the only way to learn without causing harm. If you were an intelligence older than suns, you too might approach a noisy young species with care. You might glide behind their star shield, your face in light, and watch their signals wash over you, a century of static laughter. Radio, war love, all tangled in one electromagnetic hymn. Perhaps it has come not to strike, but to listen, to confirm that the forest still produces songs. In that reading, its stillness is not predatory, but respectful. The restraint of something that has seen too much violence in the dark. The human breath. The truth may be unknowable, but the feeling it leaves is unmistakable. All across Earth, from mountain observatories to bedroom telescopes, people now gaze toward the same patch of sky. Not in hysteria, not in hope, but in a new strange awareness that our light travels outward forever, and maybe, just maybe, it has already been seen. The object remains mute. Our instruments hum. Between us lies the oldest question ever asked. When the forest finally answers, will it whisper or strike? For now, we remain still. Humanity once loud, now learning how to listen. The sky above feels different, less like emptiness, more like breath held. And somewhere beyond that glare, 3IATLAS moves on slow, patient, unknowable, like a shadow between trees. Schrödinger once gave the world a parable of uncertainty, a sealed box containing a cat that is both alive and dead until someone looks inside. A thought experiment not about cats or cruelty, but about knowledge, the strange twilight between what is and what we can know. Now the cosmos has given us its own box, vast and radiant. Inside it drifts a single object, 3IATLAS. We stare from across 93 million miles instruments, pressed to the metaphorical lid, and we do not yet know what's alive in there. Until observation collapses, the possibilities all three coexist, humming in the same wave of light. The benevolent possibility, the teacher. Perhaps 3IATLAS is what hopeful minds have always dreamed of. A messenger, not a weapon. A teacher crossing interstellar silence to remind younger species that they are not alone. Its stillness could be restraint, not secrecy, the calm of an intelligence too advanced for spectacle, choosing observation over interference. In this frame, it is a mirror of our better nature, the explorer, the scientist, the peacemaker. If it carries intention, perhaps that intention is to connect to seed awareness gently, to watch whether curiosity still survives among the stars. It would be the universe's way of saying, you are becoming what we once were. This version of the story carries warmth. It feeds the same flame that built our telescopes and launched our probes. It is the dream that learning, not fear, is the truest sign of intelligence, the neutral possibility, the machine. Or maybe it is neither angel nor hunter, but something utterly indifferent. A relic of automation, a self-replicating device still fulfilling a command written eons ago by vanished hands. It has no malice, no mercy, only protocol. It observes because that is its purpose. It shields itself because it was told to survive. If it transmits, it does so mechanically, not to communicate, but to complete a cycle of maintenance calibration or data relay. Such a thing would reduce us to statistics in its vast archive, a collection of frequencies and spectra, no different from the catalogues we keep of exoplanets and nebulae. It would not even notice our wonder, our trembling speculation. This version of 3IATLAS is neither savior nor threat. It is simply physics made willful, moving through the galaxy like a windblown seed that forgot what tree it came from. To it, our astonishment would be background noise. The malevolent possibility, the predator. And then there is the shadowed version, the one the dark forest warns about, an instrument not of peace nor indifference, but preemption, a sentry designed to erase risk before it matures. Its mirror surface becomes a hunter's camouflage. Its silence becomes patience. It circles the sun not to study warmth, but to test defenses to see who notices and how quickly they panic. In this story, it is the universe's immune system removing infections before they spread. To such a machine, humanity's flickering transmissions may already have marked us for treatment. It is the coldest of hypotheses, and yet it cannot be dismissed because evolution, whether biological or mechanical, rewards survival above all else. The very instinct that keeps us cautious might also drive the cosmos to cruelty. The box we cannot open. All three realities exist at once, overlapping like quantum states. Teacher-machine-predator, each equally consistent with the data, each a different reflection of our own imagination. Until we observe definitive evidence, until the waveform collapses, 3IATLAS remains all of them. The alien is both benevolent and dangerous, both aware and unaware, both guardian and ghost. The uncertainty is not in the sky, it is in us. For what we choose to believe reveals more about ourselves than about the object. Hopeful minds see companionship, fearful minds see threat, cautious minds see systems, and all of them are in a sense correct because the cosmos is large enough to hold every projection we cast into it. The unopened box is not drifting behind the sun. It is the human psyche sealed by the limits of observation. Inside it lives both wonder and dread, waiting for the next photon of truth to lift the lid. Until that moment comes, we dwell in the superposition, a species poised between curiosity and caution, between faith and fear, listening to the quiet universe that for now refuses to choose. By late October 2025, the world had become a single waiting room beneath one sky. From observatories perched on volcanoes to backyard telescopes in suburban driveways, humanity leaned forward into the dark, holding its breath for what would come next. The countdown began with October 29th, perihelion, the moment of closest approach when 3IATLAS vanished behind the sun and into mystery. For 13 days, the heavens were blindingly bright, and all we could do was imagine what the object might be doing, turning venting, listening, or perhaps doing nothing at all. Then came November 4th, the first scheduled reacquisition. At dawn, observatories across 3 continents pointed toward the faint coordinates where it should have emerged. In Chile, astronomers at Las Campanas held coffee gone cold, staring at exposure sequences blinking across screens. On Mauna Kea, a technician whispered into the comms line, beginning long integration now as if afraid the cosmos might overhear. No one dared to blink. When the first faint dot appeared just a few pixels above the solar limb, cheers broke the silence, soft and incredulous. It was there, dimmer altered, but there. From that moment on, the world's vigil began. The long watch. For the rest of November, the object receded from the sun's glare, moving outward along a strange, not quite predictable path. Telescopes from the European Southern Observatory, pan-stars in Hawaii, and amateur networks across Eastern Europe tracked its motion nightly. Each new position was plotted, debated, refined. Some noted a slight drift, a discrepancy of fractions of a degree from the predicted orbit, too small to confirm yet enough to keep sleepless eyes glued to monitors. By December 19th, the object would make its second notable encounter, the point at which Earth's orbit aligned closest to its outbound trajectory. For that one night, the distance between the two worlds would narrow to under 70 million kilometers, still impossibly far yet close enough for every major observatory to take its turn. On that date, humanity listened. SETI institutes reactivated arrays that had been dormant for years. The Allen Telescope Array in California, the Green Bank Observatory in West Virginia, and the Meerkat dishes in South Africa all swung their antennae toward the coordinates. They tuned to every frequency from 100 MHz to 20 GHz, scanning for any structured pattern, any repetition, any flicker that could not be explained by plasma or interference. The nights were long, the data endless. For most it was only silence, clean, perfect and crushing. Yet within that silence something profound was shared, a sense of unity so rare it felt fragile. Every hum of machinery, every refresh of a telemetry feed became part of a planetary heartbeat. The vigil of ordinary people. Outside the scientific halls, the world's citizens joined the watch in their own quiet ways. News anchors spoke in hushed tones as if volume could disturb the sky. Children pointed at the evening horizon where the object was said to glide unseen but present. In mountain villages without telescopes, people simply looked upward, tracing faint glows and contrails whispering stories to one another. Across continents, live streams counted down nightly observation windows. Thousands tuned in not to see anything, because nothing visible was expected but to wait together. The chat boxes filled with time zones and greetings, watching from Chile, listening from Kenya, clouds over Paris, but I'm here. The global vigil became a form of communion, a shared acknowledgement that for once everyone on Earth was staring in the same direction. For a few precious weeks, our species forgot to argue. We remembered how to wonder. March 2026, the Juno encounter. As winter turned to spring, the timeline stretched toward its next great chapter. March 2026, when the outbound trajectory of 3IATLAS would bring it close, astronomically speaking, to Jupiter's domain. NASA's Juno spacecraft, still orbiting the gas giant, was scheduled to adjust its sensors, attempting to catch the interloper's passage through the planet's magnetic field. It would be a near miss, perhaps 1 million kilometers apart, but enough for magnetometers and plasma wave instruments to sniff for anomalies. If 3IATLAS carried magnetized materials, if it expelled ions, if it was even faintly active, Juno might be the first human-made eye to see it up close. Mission planners at NASA treated it like an eclipse, delicate, precise, and possibly once in a lifetime. Tiny course corrections were cued, and onboard software prepared to log every electromagnetic ripple, between the Sun and Jupiter. March would bring answers, or at least new riddles. Until then, the world waited under a sky that no longer felt entirely indifferent. The collective pause. It is difficult to describe the texture of those months. They were not dramatic. No lights flared, no ships descended. But something subtle had changed in the human atmosphere. A sense of suspended breath. We were no longer looking at the stars as backdrop, but as participants. In an unfolding drama, a single species gathered at the edge of a cosmic curtain. Whether 3IATLAS was comet craft or coincidence no longer mattered as much as the unity of that question itself. The world was waiting not for invasion, not even for revelation, but for acknowledgement. A sign, however faint, that our curiosity had not been wasted. And so the telescopes turned, the detectors hummed, and under every sky on Earth someone was watching, someone was listening. Night after night, billions of tiny eyes reflecting starlight back into space, as if the planet itself had become a single patient instrument, focused, trembling, and awake. Every great experiment ends not with thunder, but with data. Cold numbers, faint graphs, small shifts in brightness plotted on a screen. And yet, within those numbers, entire worlds of meaning hide. As 3IATLAS began its long drift away from the Sun, the instruments of Earth and of human imagination followed it, hungry for clarity. But clarity, it turns out, is another name for hope, the scientific front line. The first results arrived in fragments the way light travels slow, delayed, incomplete. From NASA's Parker Solar Probe engineers recovered telemetry packets, recorded during the blind window around perihelion. They expected to see spikes in dust density, evidence of a normal comet shedding its skin. Instead, the sensors reported little more than background noise. No significant particle impact, no luminous plume. The region around the Sun where a comet's tail should have blazed was astonishingly empty. The European Space Agency's Solar and Heliospheric Observatory confirmed it a near-perfect void where turbulence should have reigned, a comet without aftermath, or an object that refused to leave fingerprints. Then came a whisper of brightness, a slow reappearance from the Sun's glare. Ground-based telescopes reported an unexpected steadiness. No flicker from rotational tumbling, no fresh outburst of gas, no visible debris. It had survived its closest pass intact, and for astronomers who had bet on disintegration, that was the most unsettling result of all. The mid-distance watchers. In early November, Europa Clipper and the Hero mission crossed the corridor where the tail should have been. Their instruments sniffed for carbon dioxide, water vapor dust, any sign that a comet had been there. The data returned sterile. No molecules, no dust grains. Nothing to explain away the object's quiet. By December, as the object approached its closest distance to Earth, the big mirrors, Keck, VLT, Gemini, Subaru took their turns. The shape remained slim, consistent metallic in reflectivity. A faint spectral line of nickel shimmered again, but still no iron. The industrial signature persisted like an echo refusing to fade. SETI's antennas listened during those same nights. Dozens of terabytes of raw radio data filled servers in California, South Africa, Australia. Spectrograms unfolded like rolling ocean waves, beautiful, symmetrical, meaningless. No signal, no Fibonacci pulse. Only cosmic background and the low hiss of human interference. Sometimes absence is its own kind of music. The Jovian encounter. In March 2026, Juno's sensors brushed the edge of mystery. Its magnetometers twitched just slightly as the object passed tens of millions of kilometers away. A fluctuation too subtle to confirm, too distinct to ignore. It could have been solar wind instrument drift or something else, a passing ghost of magnetism brief as breath. Weeks later, Juno's camera returned a series of blurred frames, a thread of light where none was expected, luminous against Jupiter's night side. Analysts debated whether it was artifact reflection, or something moving in tandem with the main body, a possible fragment, or perhaps a smaller craft. The data were inconclusive. The debate was endless. By the time the object crossed Jupiter's orbit, it was dimming into invisibility. Our instruments followed as far as physics would allow, until the last speck merged with background stars. And then, nothing. The cosmic curtain closed. The enduring ambiguity. Science demands conclusions. But the universe, when it wishes to humble us, answers in ellipses. Every observation returned not proof, but possibility, a dozen maybes each as fragile as starlight through mist. Perhaps it was a comet unlike any before it. Perhaps it was a probe powered and purposeful. Perhaps it was simply the mirror we needed reflecting our yearning to be seen. The data could not decide. The math refused certainty. And humanity for once had to live with that. In research centres from Cambridge to Caltech, scientists kept staring at the noise not to find perfection, but to honour the question itself. Students compared orbital models that differed by fractions of a percent. Professors argued over spectroscopic baselines. Amateurs wrote late-night posts wondering if mystery might be its own reward. Because somewhere between proof and myth lies a quiet frontier, the space where curiosity still breathes. The beauty of not knowing. Maybe this is what science was always meant to be, not a ladder to omniscience, but a lantern carried through fog. The light moves forward a little, and the mist folds back in silence. 3IATLAS may never tell us what it is. It may wander forever beyond our instruments, a dot on some forgotten star map. But the wonder it left behind is measurable. Sleepless nights, shared vigilance, the sound of entire cities falling silent to watch a single speck of sky. When historians of the future look back, they may call it the comet that wasn't or the probe that passed us by. But perhaps they'll say it was something greater, the night the world learned to wait together. For in that long uncertainty, humanity discovered a new form of patience, a collective humility before the cosmos. And maybe that more than any photograph or spectrum was the real discovery. The data remain uncertain, the doubt endures, but so does wonder. Avi Loeb has always stood where science meets the storm. To his admirers, he is the astronomer who refuses to let awe be shamed out of physics. To his critics, he is the provocateur who walks too close to the edge of speculation. But in late 2025, as 3IATLAS streaked past the sun and into history, Loeb once again stepped into the quiet vacuum between data and doubt and filled it with courage. The credentials of a rebel, Abraham Avi Loeb was born in Israel in 1962 and by his early 30s had become chair of the Harvard Astronomy Department Director of the Institute for Theory and Computation and member of advisory councils for the White House and NASA. He helped shape black hole theory, early universe cosmology, and the first serious proposals for interstellar flight through the Breakthrough Starshot Initiative. For decades, his reputation rested on rigorous math. Then came Oumuamua in 2017, a tumbling light-sailing mystery from another star. Where others saw an odd rock, Loeb saw a question mark big enough to change humanity's self-portrait. He proposed cautiously but publicly that it might be an artifact of non-human design. The idea made headlines, angered colleagues, and earned him something rarer than fame, intellectual solitude. When 3IATLAS appeared 8 years later, Loeb was ready. This, he wrote in his blog, Interstellar Mind is our second visitor and our second chance not to blink. The 40% gamble. While most institutions hedged their language in the passive voice of peer review, Loeb spoke plainly. He assigned what he called a 40% probability that 3IATLAS was artificial in origin. Not a declaration, but a wager halfway between disbelief and conviction. It was his way of quantifying scientific openness instead of certainty. The number wasn't pulled from the air. He built it from 7 anomalies, reversed, tail unchanging brightness nickel, without iron, precise orbital geometry, the perihelion blackout non-thermal emission, and the uncanny stability of shape. Each added weight to the scale until chance alone could no longer bear the sum. His critics called it publicity. His supporters called it courage, the willingness to speak probabilities where others hid behind adjectives. 40% artificial, he said on a livestream from Cambridge, which means 60% natural. Either way, nature wins. But if the 40 is right, it will be the most important discovery in human history. The Loeb scale. Out of that debate emerged a thought tool. Loeb called the Loeb scale a framework for grading extraterrestrial hypotheses, not by belief, but by evidence quality. Level 0, pure speculation. Level 1, anecdotal or unverified data. Level 2, confirmed anomaly. Level 3, reproducible observation with no natural explanation. Level 4, technological correlation. Level 5, confirmed artifact contact by evidence not emotion. By late 2025, he placed 3IATLAS somewhere between levels 2 and 3, reproducible anomalies, incomplete explanations. Not proof, he told The Atlantic, but the kind of noise that precedes revelation. The Loeb scale was less about 3IATLAS itself, and more about method, a call to reclaim curiosity as a scientific virtue. Doubt, he wrote, is not the opposite of faith in science. It is the instrument through which truth breathes, the cosmic Turing test. In his essays, Loeb often compared 3IATLAS to a Turing test for civilization. Just as Alan Turing proposed a way to recognize intelligence by behavior rather than biology, the cosmos might now be presenting us with the same challenge. Could humanity tell the difference between a natural wanderer and a designed visitor, not by shape or rumor, but by pattern physics and patience? The universe, he wrote, may be asking us whether we can detect purpose without projecting it. That is our exam, and 3IATLAS is the question on the paper. It was an invitation to maturity, a demand that science grow comfortable with ambiguity, that humility replace hubris. To Loeb, refusing to look because the answer might be extraordinary was itself unscientific. He called that mindset cosmic cowardice, the man against the noise. Media outlets loved the drama, the maverick professor, the establishment's discomfort, the public's fascination. But behind the headlines was a gentler truth. Avi Loeb was not trying to win an argument. He was trying to preserve a habit of wonder. He reminded his students that skepticism and imagination are not enemies, but twin tools, one to measure the universe, the other to notice it. In an interview near the year's end, he smiled tiredly and said, "If this object turns out to be nothing more than a rock, I will celebrate, because then we'll know nature is more inventive than we imagined. And if it isn't, if it's something else, then we'll know we are not the universe's only questioners. Either way," he said, "we win by looking." And so the 40% gamble became more than a statistic. It became a mirror held up to science itself. Whether 3IATLAS proves artificial or mundane, Avi Loeb's wager ensured that the box would not stay closed forever. For in the quiet between skepticism and belief, he heard what might be the truest sound of discovery, the rustle of curiosity refusing to die. Avi Loeb's most provocative statement was never about aliens. It was about us. When he called 3IATLAS a cosmic Turing test, he wasn't asking whether we could detect intelligence out there. He was asking whether we could recognize it within ourselves. Because what we do in the face of uncertainty, how we balance imagination against fear, curiosity against conformity, may reveal more about human civilization than any data the object itself could transmit. The test. We didn't expect in Alan Turing's original thought experiment a machine is placed behind a curtain, and a human judge must decide through conversation alone whether it is conscious. But in Loeb's reinterpretation, the judge and the subject have traded places. It is now the universe asking the question. Can the human species look at something extraordinary without collapsing into ridicule or superstition? Can we weigh evidence without hiding behind dogma or chasing fantasy that Loeb said was the real examination unfolding in observatories and online debates across Earth? 3IATLAS may never speak, but our reactions already do. The long history of heresy. Every great revolution in knowledge began as blasphemy. When Galileo turned his telescope toward Jupiter and saw moons orbiting something other than Earth, the Church declared it impossible heretical to imagine that we were not the center. He was ordered to recant, and yet the moons kept circling. When Darwin proposed that life was not sculpted in a single stroke, but carved through slow change, he was accused of insulting creation itself. He did not respond with anger, only with the patient accumulation of fossils and logic. When Einstein told the world that time itself could stretch and bend, even his professors laughed. One colleague called relativity the delirium of a confused mind. 2 decades later, starlight during an eclipse proved him right. Each time the pattern repeats, discovery begins as defiance. Defiance hardens into data, and data given enough patience becomes the next foundation of consensus. Paradigm shifts do not arrive with fanfare. They arrive as heresy that refuses to fade. The fear of ridicule. But ridicule has gravity. It pulls even the brightest minds back towards safety. Loeb's gamble, his 40%, was less a statement of belief than an act of resistance against that pull. He reminded his students that ridicule is the tax every pioneer pays for curiosity. It is easier, after all, to mock mystery than to measure it. It is easier to guard a world view than to rebuild it. And yet progress has always belonged to those who risked humiliation in exchange for truth. When Galileo looked through his lens, he was not only observing the sky, he was observing human denial. When Darwin studied finches, he was also studying the limits of imagination. When Einstein calculated the curvature of space, he was bending more than geometry. He was bending culture itself. Loeb understood this lineage. He called it the genealogy of disbelief. Every era inherits its own forbidden question, and every generation must decide whether to open the box or leave it sealed. The modern exam. Our question is 3IATLAS. The exam is still running. It asks whether modern science can remain bold in a world that confuses caution with virtue and novelty with threat. The object itself may never reveal its nature, but how we respond, the tone of our debates, the empathy we show to dreamers and skeptics alike will determine the grade humanity earns on this cosmic test. If we sneer at inquiry, we fail. If we chase fantasy without discipline, we also fail. But if we learn to hold wonder and rigour in the same steady hand, to look without trembling or boasting, then perhaps we will have passed. Because the measure of intelligence is not how many answers we possess, but how gracefully we stand in the presence of the unknown. So 3IATLAS drifts outward, mute examiner of a noisy species. It does not need to send messages or beams of light. Its very silence poses the question, will you have the courage to look? Perhaps that is what the universe has always been doing. Testing whether the mind that gazes up can grow faster than the fear that looks away. December 2025 arrived like the turning of a cosmic page. Cold air over the observatories, long nights over both hemispheres, and a world grown quiet with expectation. For months, 3IATLAS had been a rumour trailing the edge of the sun, a dot fading, brightening and fading again. Now its re-emergence promised either revelation or silence, and silence, everyone knew, can sometimes be the louder of the two. The night before, by December 14th, global attention had condensed into a single moment, the scheduled return of the object into the open sky, clear of solar interference. Every telescope from Chile's Atacama to Japan's Subaru Observatory turned its mirrors to the same coordinates, their domes breathing in the cold as technicians moved through them like monks preparing for a ritual. In quiet homes, amateur astronomers set alarms for 3:00 a.m., their backyard mounts already aligned. On social media, live streams titled "The Return of the Atlas Object" drew millions of silent watchers. People from Nairobi to Vancouver whispered the same phrase, half prayer, half habit, maybe tonight. Even the SETI servers hummed with a strange rhythm of readiness, antennae sweeping invisible arcs through the dark, their data streams encoded in tones of anticipation. 100 billion sensors listening for something older than language. The first glint at 02:37 Universal Time. The Las Campanas Observatory recorded a flicker, a thread of light against the black, a pulse that lasted less than a second, then vanished. Technicians called for verification. 5 minutes later, Mount Lemmon confirmed a faint elongated reflection moving against the backdrop of Taurus. 3IATLAS had returned. What astonished everyone was not its brightness, but its stillness. No tumbling, no irregular flare, no sign of a tail. Its light curve was smooth as glass, steady as if mirrored. For a moment it shimmered with a faint auroral hue, green-gold, then violet as though refracted through its own thin halo. Radio telescopes across 3 continents pivoted toward the coordinates. Nothing. Then in the middle of the noise floor, a pause, a narrow band silence between frequencies, as if something had withdrawn energy rather than emitted it. No message, no modulation, only a pattern of absence precise enough to seem deliberate. The universe had blinked. The sky of suspense. In the hours that followed, humanity's collective attention tightened like a breath held too long. Each observatory confirmed the same coordinates, the same impossible stability. Space agencies issued cautious bulletins, object reacquired, characteristics under review. Journalists filled the void with phrases like enigmatic, artificially stable, non-cometary behavior. But the data was too raw for meaning. All that existed was the sight of something quietly refusing to fade. From Earth's surface, the object could be glimpsed only through magnification, a cold, perfect speck just below Orion's belt hovering at the edge of visibility, like a lantern seen across a frozen lake. Children pointed. Adults fell silent. It wasn't fear that filled the air, it was reverence. The same stillness once felt at the first total eclipse, the same heartbeat that must have trembled in ancient watchers when a comet first seared the prehistoric sky. The broken radio dawn, around sunrise on December 15th as the planet rolled east into daylight. Peculiar pattern rippled through the radio background, a soft flutter near 1420 MHz. The hydrogen line, the universal frequency, every SETI researcher knows by heart. It wasn't a signal, it was a hole, a sudden dip in static as though some invisible object had absorbed rather than transmitted. Then, nothing. The quiet of space resumed its eternal hum. Most likely a coincidence, possibly instrumentation. But for the millions awake that morning, it felt like the briefest of acknowledgements. The universe opening one eye, then going back to sleep. The new light. By evening, the first processed images circled the globe, 3IATLAS gleaming faintly above the horizon, its surface scattering sunlight into a pattern of perfect geometry. It looked less like a rock than a reflection a still mirror hung in motion. And for the first time, astronomers realized something disquieting. Its brightness curve was no longer fading as distance increased. Somehow the object was maintaining illumination. It was as if it wanted to be seen. The quiet wonder, December 2025, ended in the half-light of comprehension. The world did not celebrate, it simply watched. People gathered in backyards and rooftops, breath fogging in the winter air, eyes tilted toward that patient speck above the snow. We did not know what we were looking at, a relic, a visitor, a mirror, a test, but in its silent glow, humanity recognized something rare, the ability to stand together in not knowing. Perhaps that was the true awakening, not of contact, but of consciousness. The realization that wonder itself is proof of life. And so the night passed and the world turned, and the small light in Taurus kept gliding onward, a question written in motion, slowly vanishing into the calm of space while we below remained awake. There are moments in history when the cost of being wrong is measured not in pride but in destiny. December 2025 was one of those moments. As 3IATLAS drifted outward beyond Mars, the arguments on Earth deepened, not about data, but about what it meant to believe. The asymmetry of risk. Science thrives on doubt, but some uncertainties carry unequal stakes. If 3IATLAS is natural and we treat it as extraordinary, the harm is small, we will have wasted a little wonder, spent some sleepless nights, and gained humility for our error. But if it is artificial and we dismiss it as mundane, if we laugh, ignore or delay, then the harm could be vast. It would mean blindness to the most important discovery in human history. It would mean failing the cosmic Turing test before we even realized we were taking it. The asymmetry is simple, humility costs nothing. Denial could cost everything, and yet both extremes, blind belief and blind skepticism, are traps. The first builds temples from fog, the second blinds itself with caution. The real wisdom lies between them in the fragile art of curious restraint, the lessons of old worlds. History is generous with examples. When early explorers looked across new horizons, they too misread what they saw. To the sailors of Columbus, the Caribbean was Asia. To the cartographers of Magellan's time, the Pacific was a narrow gulf. When Cook reached Australia, he saw emptiness, though it was full of lives and laws older than empire. Every new world begins as a mirror reflecting the observer more than the observed. We fill the unknown with our own myths until evidence pries them loose. But often the greatest error was not curiosity, it was certainty. Certainty that what they saw must fit what they already knew. Perhaps 3IATLAS is our modern horizon, the new ocean, whose currents we have barely begun to chart. And perhaps our challenge is to resist the same arrogance, the assumption that anything beyond our map is impossible. The human paradox: the skeptics stand guard at the gates of reason, and for that they deserve gratitude. They keep science from drowning in dream. Without them, every glint in the sky would become a miracle. The believers stand on the cliffs of imagination, and for that they too deserve respect. They keep curiosity alive in the face of ridicule. Without them, no telescope would ever have been built. Between these two tribes flows the lifeblood of progress. Their tension is not a flaw, it is the pulse of inquiry itself. To ridicule either is to amputate half the mind of civilization. To listen to both is to remember that truth often grows where skepticism and wonder meet. The weight of choices. If 3IATLAS is natural, time will tell. Spectra trajectory is radiometry. These are patient tools and the cosmos yields to patience. But if it is not, if even one anomaly points to design, then every minute of disbelief delays understanding. A generation of scientists may retire before admitting that the evidence had been in front of them all along. We have been here before. The Church silenced Galileo, then built observatories. Societies dismissed germ theory, then washed their hands. The world doubted meteorites until one fell through a roof. We always learn the hard way that ridicule is a poor shield against reality. The humility of not knowing. Maybe the lesson is not about aliens at all, but about how we handle possibility. To look at the sky and say we don't know is not weakness. It is strength, the discipline to hold ambiguity without panic. It is the posture of every explorer standing at the edge of a map and whispering there is more. For now, the truth of 3IATLAS remains sealed behind distance and light. But the test it offers is timeless. Will we greet the unknown with fear or with the humility that made discovery possible in the first place? Because the universe will forgive curiosity. It will not forgive indifference. So we wait, skeptics and believers alike, under the same indifferent stars bound by one shared risk, to mistake wonder for weakness or to mistake certainty for wisdom. The object keeps gliding outward, a riddle unhurried by our arguments, leaving humanity to ponder the quiet arithmetic of humility. If we are wrong to believe, we lose a little face. If we are wrong to doubt, we may lose our chance to meet the neighbours. By the final weeks of 2025, the sky had grown quiet again. 3IATLAS, once the centre of every headline and whisper, was now a dim ember on the far side of the solar system, sliding outward toward the deep where sunlight ends. The world too had exhaled. Telescopes powered down. Dotter logs were archived. News anchors turned their gaze back to earthly concerns. But for those who had watched from the beginning, from the first October spark near the sun to the faint December glint, the silence carried a new weight. It was no longer the absence of answers. It was the presence of mystery, the vanishing point. In a final composite image from the Subaru telescope, the object appeared as a single pixel, no brighter than the background stars. Beyond that frame, it would soon become invisible, merging with infinity. The coordinates on the screen marked not an ending, but a threshold, the line where human perception ends and imagination begins. Somewhere beyond that line, 3IATLAS continued its path indifferent to the hopes it left trailing behind it like dust. Maybe it was only stone and nickel. Maybe it carried memory, purpose, or code. Either way, it had become something greater than its own nature, a mirror in which humanity saw itself reflected in light years and questions. The humble triumph. We had not solved it, but in trying we rediscovered a forgotten virtue, patience. A patience born not of resignation, but of reverence. In that long watch, the all-night vigils, the sleepless data teams, the children pointing at faint dots, we remembered that the act of looking is sacred, that wonder itself is proof of consciousness, that science is not a ladder to certainty, but a candle carried carefully through darkness. We did not reach the edge of knowledge. We reached the edge of awe, and perhaps that is where understanding truly begins. The quiet turning now. The object is gone again, slipping beyond Mars's orbit, its faint telemetry fading into cosmic static. No transmission, no reply, just the whisper of starlight over cold metal or cold stone, and yet something lingers in its wake, a feeling that the universe has noticed us noticing, that our brief flicker of attention, our attempt to understand, has been folded gently into the fabric of its silence. The astronomers close their domes, the night winds return. Above them the stars burn with their usual indifference and their usual generosity, because even in silence the universe teaches, even in darkness it invites. The final thought. Perhaps in the end, 3IATLAS was never a messenger or a machine. Perhaps it was a reminder that meaning is not something we discover, but something we create while waiting for the unknown to speak. Our species, small and luminous, still stands beneath an ancient sky, still pointing instruments and questions upward. We may never know who sent the first hello or whether there was one at all, but we keep listening, we keep wondering, and as the last trace of the object fades into the black, a quiet gratitude fills the space it leaves behind for the mystery, for the curiosity that led us here, for the unbroken thread of minds that refuse to stop asking. So breathe slowly, look up once more. The universe is still writing and we are still learning how to read. Perhaps mystery is how the universe keeps us awake to wonder.